Hello and welcome back to day 2 of the Dynamic Spectrum Alliance Global Summit, a new spectrum mindset. We have an action-packed agenda today, so we will waste no more time but get straight into it. But just before we do, I just want to remind you that we have a platform for taking comments. If you have comments on or questions from the presenters, please feel free to post them within the question section on the GoToWebinar panel, and we'll try to address as many as we can. We're a little pressed for time today, so there may be some limitations, but we'll do our very best. So we are going to start with a number of keynote presentations, but first, I'd like to invite Martha to make some brief comments on the session yesterday. Martha, over to you.
Thank you very much, Steve, and good morning, everyone. Welcome. Good morning, good afternoon, good evening, depending on where you are. Welcome to this second day of the DSA Summit. So today we are having, we will have a lot of presentations from different key stakeholders from different countries. And I wanted to summarize about our session yesterday or this morning in Asia Pacific region. We had great comments and insights from regulators from different countries, and also those that have been working, for example, on the 6 GHz implementation. So we had a panel about that. And then after, we had a keynote from Dr. Ismail from Indonesia. So I invite you to see all that content that will be available online if you missed the session. And yeah, for today we are ready. We will have first keynotes from regulators and authorities, and then we will have a panel from industry with different industry stakeholders. So I hope you will enjoy this session too.
And our first session today is a fireside chat between Martha and Jessica Rosenworcel, the acting chairwoman of the FCC. So many interesting things have happened with regard to spectrum regulation in the US. I'm really looking forward to this chat. Unfortunately, Jessica's unable to join us via video, so it will be an audio-only experience. Over to you, Martha.
Thank you, Steve. And acting chairwoman Jessica Rosenworcel, it's really a pleasure for DSA to have you here today with us. And we really appreciate your time and thank you for joining.
Thank you, Martha. It's a treat to be with you and to talk about a new spectrum mindset. I like the title of this gathering.
Thank you very much. And well, let's start the discussion. I know how passionate you're about closing what you call the homework gap. So I would like to ask you about that term. You have been using that for a while. And if you could please tell us and share with us some of the main actions that the FCC has undertaken under your leadership on this important challenge.
Sure. In the United States, this pandemic has really demonstrated that broadband is not just nice to have, it's need to have for everyone, everywhere. And honestly, nowhere is that truer than when it comes to students. We have 17 million students in this country who struggled during the pandemic and couldn't go to online class because they don't have reliable and consistent broadband at home. And I've come to calling that the homework gap, because many of these students have broadband and internet access at school, but they can't do their nightly schoolwork because they go home and they don't have access that they need for math, English, science, what have you. And so during this pandemic, it's been really hard for them, and they've been, in many cases, locked out of the virtual classroom. So I have been working for some time now to see if we can develop a fund to help address the homework gap and help every student in this country get online for their education. And I'm proud to say that last month, the Federal Communications Commission put in place rules for a $7.17 billion homework gap fund called the Emergency Connectivity Fund. We are going to open for applications later this month, and it will let schools and libraries all across the country apply for funding so that they can get Wi-Fi routers, laptops, modems, and other forms of connectivity for students to help connect them at home so they can continue with their education. I think this is going to be really helpful in closing the digital divide and solving that homework gap. And I'm proud of the bipartisan work at the agency we've done to make this possible.
That's amazing, great. And I like what you're saying about schools and anchor institutions like libraries. I think that it's really important to consider connectivity for them. And I think many other regulators might be interested in hearing about that experience. So thank you very much, very exciting news. And now I would like to focus on some specific decisions of the FCC that, you know, we have followed how you have supported them for a while. So I would like to focus now on the 6 gigahertz band. So could you please tell us about the reasons why the FCC decided to enable unlicensed access to that band from 5925 to 7125 megahertz?
Sure. I think what the Federal Communications Commission did in the 6 gigahertz band is quietly revolutionary. I mean, we set aside 1,200 megahertz of spectrum. That's the largest opening of spectrum for unlicensed activity in the agency's history. Now, there were lots of proposals to reserve some of this for exclusive licensed use, but we didn't do that. We decided all 1,200 megahertz would be unlicensed, which is going to enable 160 megahertz wide channels, much faster speeds, higher capacities. And I think this is really important for a few reasons. The first is that having more unlicensed spectrum available democratizes internet access. It also is it fosters all this economic activity because permissionless innovation can take place when there's that much unlicensed spectrum. And then finally, I think we have to be mindful that our carriers that operate with licensed spectrum are offloading as much as 70% of their traffic onto unlicensed at some point. And most of us receive service through this mix of licensed and unlicensed. And one of the things that's happening in the United States is as fiber, cable, and mobile all start moving to gigabit plus speeds, sometimes that Wi-Fi router becomes the bottleneck to getting faster speeds at home. And it's like moving from a super highway onto a gravel road. But with this addition of 1,200 megahertz of spectrum, I think we're going to change that. And I'm really excited about what we've done because I think it is a big place for Wi-Fi and unlicensed innovation to grow.
Great to hear those arguments. And how do you think that this decision fits in the USA 5G vision? Because you know there is a trade-off between licensed and unlicensed spectrum access. So how would you relate? What is the relationship between the decision and the US 5G vision?
I think if you want to have a vision for 5G, you have got to consider both licensed and unlicensed activity. These things work together in a cooperative relationship. And on the licensed side, we hear a lot about operators and the deployment of 5G. But on licensed now, we're also seeing evolution as we move from 802.11ac to Wi-Fi 6. And we're going to see more range in wireless networks, fewer connection drops, better security with Wi-Fi 6. And already at the FCC, we're starting to approve Wi-Fi 6 devices. We're seeing some new models of phones include them. And so I think this really potent mix of licensed and unlicensed is a necessary part of any 5G strategy. And as we just mentioned, the 6 gigahertz band is a really important part of that in the United States.
Okay, thank you. And indeed, we had a presentation yesterday about the ecosystem and some different vendors that already have equipment available for Wi-Fi 6E. And of course, they go through the process of certification with the FCC. So it's really exciting to see that active market.
Oh my gosh, absolutely, because it's like happening. And in real time, I can see it starting to make its way to the marketplace. This is a big deal. And I can't wait to see what comes next.
Okay, and also I would like to ask you about, well, in the US, there are 2 use cases that have been approved: low power indoor applications and under power applications. I would like to ask you about how do you think that they contribute to the broadband access in the US and for innovation in general?
You know, when this pandemic upended our lives, so many of us were forced to stay home and shift work, school, healthcare, entertainment, all online. And so we took this digital leap. And sometimes I think that leap just slammed into our existing Wi-Fi networks because we had more devices running up with more applications than ever before. And so we have these new opportunities for low power indoor devices and standard powered devices in the 6 gigahertz band. And so we're going to see new devices that operate on wider channels with more capacity, broader coverage, faster speeds. And I think that's going to improve the ways that we use this technology, especially in homes and offices. And again, we're starting to already see new devices through our equipment authorization process that are making use of Wi-Fi 6. And I think I think there's a lot of innovation coming our way as a result.
Okay, and I have also heard that some ISPs in the US were using spectrum during the COVID-19, well, last year, to provide internet access for their users in rural areas or not necessarily urban areas.
Yeah, you know, we've had a lot of really creative efforts to try to figure out how we mix licensed and unlicensed and get more people connected to the services they need. So much of our modern life moved online with so much greater speed than perhaps we were ready for. But I appreciate that we've had a lot of public sector and private sector activity to help get more households online. And Wi-Fi has definitely been a part of that in expanding access, particularly in urban and populated areas.
Yes, and we are also very excited at the DSA to see the international momentum. We have been so, you know, there have been so many new countries also deciding on opening the entire 6 gigahertz band, especially in the Americas. We have seen after the US, we had the decision from Chile, from Honduras, Guatemala, Costa Rica, Peru, Canada recently, and of course Brazil. So it's really a great momentum. Would you have any comments on that?
Yeah. So the United States might have been the first, but we're not alone because momentum on this has been picking up globally. I mean, you've even mentioned some countries I wasn't aware of. I knew that Brazil, Chile, Canada, South Korea have all opened up the 6 gigahertz band for more unlicensed use. And these decisions are fantastic because they'll harmonize the spectrum around the globe and create economies of scale that'll lower the cost of devices. We'll see more innovation. So I'm proud to say we're the first, but boy, it's more exciting that we won't be the last.
Exactly, and there are also some decisions for additional use cases and new applications. So we are also excited to see how this is growing and how it's growing so fast. Also,
yeah, you bet.
Now let's talk a little bit more about the 5G vision. We just discussed before, but we know that in those plans for 5G, mid-band is crucial. It's a crucial segment of the spectrum. And we know about CBRS and how it has been fully commercial deployed since January last year. So I would like to ask you, could you share with us some of that experience and maybe some benefits and outstanding use cases that this framework has enabled in the US?
Yeah. I'm proud the United States has had this long history of experimenting with spectrum policy. You know, we were very early when it came to using auctions to distribute, but I think it's just as revolutionary what we've done with the 3.5 gigahertz band and CBRS, because really until very recently, we looked at spectrum bands and we had a binary vision. It was either licensed or unlicensed. And what was done with CBRS was different. We said, here's 150 megahertz of spectrum, and we'll create a hierarchy of rights where we might have some very occasional government use, and they have preemptive rights. But that use is so occasional, we'll make licensed spectrum available when they're not using it. And then to the extent that's not being used, we'll have unlicensed available. And that hierarchy of rights was a totally different kind of spectrum auction than the FCC has ever held before. And in many ways, it really was a wild success because we've seen incredible investment in this band. But I'd also point out that the number of licenses that we had won at auction, more than 20,000, was larger than we saw before. And the number of bidders, 228 that won, was the most number of bidders we've seen in an auction to date. So this is the evolution of how we think about spectrum policy, how we break away from that old construct of strictly licensed or unlicensed, and how we evolve our auctions in more creative ways to make use of our airwaves. We've already seen a whole bunch of new use by WISP, by MNOs, by utilities and enterprise. And I think that we're going to see very fast innovation as a result of the framework we used in this band. And I hope that we can find other ways to use it going forward.
Great. And I might ask you also something I commonly hear from regulators and authorities in other countries. It's like, how can you mix all that, like having all those use cases and making sure everyone is working together? I mean, like everyone has access to the resources they need. Could you please provide also?
Yeah, so we are using spectrum access systems and to make sure that everyone in a non-technical way stays in their lane, doesn't cause interference. And I think here's something else that's unique about our approach. Instead of having the government run that spectrum access system, we made a competitive market for it. And we would come in, we had spectrum access systems come to us, we validated that they work appropriately, and we now have 6 of them. And I think that that competition is important and has enabled commercial operation. So it's one of those things we'd be happy in the United States to share our experiences with others, because this is a really creative model for auctions, and it would be neat to see what other nations could do with it if they have the opportunity.
Great. And I think it's a great mix between choosing a band that has a wide ecosystem in terms of equipment and devices, but also creating a large ecosystem for final users, those that need a license and those that can operate on a general authorization.
Right, right.
Excellent, amazing. And I would like also to ask you about mid-band in general. So we have the CBRS framework, but we know also that the FCC has had the auction of 280 megahertz C-band, and now is preparing also for the assignment of 3450 to 3550 megahertz, and also is studying about additional spectrum in the 3100 to 3450 megahertz. That's under consideration using spectrum sharing mechanism. All that is a huge effort. I mean, you know, when I'm listing just all those segments of the band. So I would like to ask you about all those ongoing activities and which are the expected outcomes.
Yeah, I think that the United States, candidly, during the last several years was slow to recognize the importance of mid-band spectrum for 5G and a little late to bring these airwaves to the market. We are catching up now. And you see that first in the C-band, where we're making available 280 megahertz of spectrum for new mobile use. And that auction, candidly, brought in $80 billion, which is a record. There's a lot of pent-up demand for mid-band spectrum from our operators. And those airwaves are going to be available, the first lower 100 megahertz by the end of 2021, and the next 180 megahertz by the end of 2023. We are also holding an auction in October this year of the 3.45 gigahertz band. That's 100 megahertz. And we're starting to have discussions about what might be possible in the 3.1 to 3.45 gigahertz band. Though I'm mindful we will have to work with federal government authorities that are using that band right now and identify what relocation is required. And increasingly that issue of relocating federal government users so that we can have new mobile opportunities or licensed or unlicensed is challenging because the costs of relocation are candidly getting high. And we have a law in the United States called the Commercial Spectrum Enhancement Act that requires the FCC through our auctions to pay for 110% of those relocation costs. So as the costs get higher for relocation, it tends to constrain what we can do when it comes to auction structure. And I hope that's something that we can look at in the future too, because these are challenges and I don't want them to constrain our creativity going forward for both licensed and unlicensed spectrum.
Yeah, and in fact, that's one of the main advantages of the spectrum sharing, is that you, instead of having, sometimes relocations are expensive, I mean, most of the time they're very expensive and they take time. So, and spectrum sharing is a way to have access to the market a little bit faster and also without having those relocation charges. Yeah,
no, absolutely. You know, the terms of that spectrum sharing, this is one of those things that where the devil's in the detail, you know, how often, how frequently, what constraints, and to what extent, you know, do you have an assumption of continuing availability so that you would build infrastructure out that makes it truly useful?
Yeah, exactly. And you mentioned about international cases. So other countries don't have exactly the same situation of the US and such a hard and complex environment for sharing. But we are hearing more and more interest on dedicating spectrum for verticals and industry applications for wireless internet service providers that would like to offer broadband connectivity solutions using 3GPP technologies. We are also hearing from neutral hosts that would like to support network deployment. So we are seeing a lot of interest from different stakeholders that would like to have access to spectrum for mobile communications. We are going to hear just after this presentation from Philip Marnick how the UK created some frameworks for localized and shared licenses. So we are going to hear some updates on that. Germany decided to have dedicated segments, and we heard yesterday from Vanessa on that. So I would like to ask you, and from your experience with CBRS and that larger ecosystem, what would you like to say to those regulators in other countries that are considering spectrum sharing opportunities in mid-band?
This is so interesting because in the United States, we've had a really different approach during the last 2 decades. We have had a deep bias towards technological neutrality and flexible use spectrum. So we have been, over the years, less and less likely to take certain bands and say these are the certain uses that are permitted, or this is the type of innovation we wish to foster in certain industry verticals. And I think that that's been largely effective in the United States, flexible use, technological neutrality. But at the same time, you know, as someone who's interested in spectrum, we'll be looking to see what other nations are doing, Germany and the UK, as you mentioned, with things like setting aside spectrum for IoT uses and specific industry elements. Though this has generally not been the way that the United States has been operating in recent years. We just have a deep bias towards flexible use.
Okay, but you have with CBRS, you created the opportunities for those that are basically MNOs to also have access to the spectrum.
Yes, and I would say that that's sort of like a halfway step there, though, because it's not industry specific. It's not like a vertical in the same way that I think is being contemplated in some of these other nations. But you're right, that's a slightly different version of flexible use. But it, when we started the 3.5 gigahertz band, we also talked a lot about using them custom built for small cells. So we're mindful that there are ideal use cases, but we're also open to industry creating others, and flexible use allows that to take place.
Okay, and as you mentioned, with the results of the auction of priority access licenses in CBRS, there was a lot of interest, and not exclusively from industry, right?
Right. No, I mean, the most exciting thing about CBRS is like the universe that came and won licenses is very diverse. And, you know, as a general principle, if you hold auctions and you have lots more industries and operators interested, that's an awesome thing. So we have to study that and see if we can continue to encourage it going forward.
Great. And well, we are almost about to finish our discussion. So I would like to take the opportunity to ask you, personally, I think that it's important to see more and more women in leadership positions. And in your case, you are clearly a role model for many women. So I would like to ask you if you have any advice or any conseils for women that are starting their career, not only in the US, but also worldwide, and that are interested in ICT.
Oh my gosh. Well, first of all, this is one of those strange things. It's like I'm talking to you, you're a woman running an organization, I'm running one. This doesn't happen to me in my day-to-day. I mean, the best part of my job is that I get to see up close and personal a whole bunch of the newest technologies, and, you know, I get advance notice of the next big thing. But it's terrific to be in the room where it happens. But one thing I've noticed about sitting at that table is there aren't a lot of women sitting there. I've been the only woman in most of these rooms for a long time. I'm still the only woman who's serving at the Federal Communications Commission. And there's definitely some dynamos who have blazed the trail before me, like former acting chairwoman and Commissioner Clyburn. But it's pretty amazing to me that almost 100 years at the FCC, there's never been a woman who's run it. And it's still amazing to me that I visit conferences and spend time with investment and actors and engineers, and I'm, again, the only woman at the table. So my advice to people generally is that if you get the ability to sit at the table where decisions being made, in a room where it's all happening. You should be the person who pulls up a chair for someone else, you know, be a mentor, be a sponsor, be the person who brings others along. And I think if we all commit to that, the places where decisions are being made will get a little more diverse. We'll see some more women, and I actually think we'll make a whole lot more progress.
Thank you. And sorry for going a little bit far from the spectrum, but I think it's really an important message.
Oh, absolutely. No, I appreciate you making mention of it. Thank you so much, Marta.
Okay, so Acting Chairwoman, it's really a pleasure to have you with us today. Thank you very much for all the insights and all these open comments. I'm sure that other regulators and authorities will appreciate. And well, thank you again, and all the best in your activities.
All right. Hopefully we can do this in person next time. Please take care. Bye-bye.
Okay. Bye-bye. Thank you.
Thank you very much to both of you for a fascinating conversation. And time presses us, and I think we have to move directly on to our next presenter, which is Philip Marnock, Group Director of Spectrum at Ofcom. And I have to say, one of the things I really appreciate about Ofcom is not just the innovation that comes from the agency, but the fact that you do such an amazing job of documenting and communicating it. Your website is a reference for many. Anyway, looking forward to hearing you. Over to you, Philip.
Thank you very much indeed. And thank you very much for inviting me along to this event. It's a great pleasure. It's a shame that we can't be there in person to do it. And it's a great pleasure to follow on from Jessica and to talk about some of the things we're doing on the different side of the Atlantic from the Americas. For us, what I was going to talk to you today about is actually some of the things about what we've been doing and sharing, but actually the new spectrum strategy we've been trying to put into place as we move forward. Because I think, as was just said, we are at a change. We've here always been technology neutral. You know, spectrum bands are for the purpose you wish to use them for. We don't restrict the technology, but we do make them exclusive or not. So we move to the next slide, please, if you don't mind. We've consulted recently on our new strategy. And our strategy is looking at how we're going to think about spectrum moving forward over the next decade. We also undertake particular strategy views for sectors. So we'll look at what's going on in mobile, we'll look at what's going on in space and science and satellites, and then put up plans in place for those, or what we're going to do with bands and what we're going to think about how we do it. But this is our overall approach, what we're going to do. So we've started with defining a new vision. What do we want to happen and what do we want to enable? And one of the things for us is actually innovation is really important. The speed at which change is occurring is getting faster and faster, and we need to be able to respond. But we also need to be able to let things happen. But you're making spectrum available for people to use them. So what we want is continued improvements in the way wireless communication is used by everyone, wherever and wherever they are. So basically, you can use wireless anywhere. We want for the businesses, the public sector and others, these are organizations that have specialist demand. So something unique, whether it's a military radar system, whether it's some business who needs applications for doing it, whether it's an airport, whatever it is, we need to make sure we understand those needs and we build them in to make sure they're not constrained and that we continue to grow. What we're trying to do then is to make sure that when we move forward, we're providing flexibility in the way we make spectrum available. We want to support innovation. Now, regulation supports it, we can't make it happen. But innovation is the thing that other people do. So we want to make sure that the spectrum is there to enable people to have this. But we also want to make sure that if you do something, we can give you some assurance that actually you'll be able to continue doing it. So not just sandboxes that you can play in and then wonder what you do, but how we let people play in the big spectrum bands and have bands that are available to enable people to grow and put things in place to make that happen. The other thing we want to do, though, is encourage and sustain improvements in the efficiency of how people use spectrum. One of the biggest constraining factors we've always had is that the next door neighbor or the people who are using it, of course, everyone can share, but I'm special. So how do we overcome that? How do we get people to think about that their neighbors will get noisier and therefore build in their own protections to make sure that nobody is an inhibitor? This is a big mindset change that we need to make, both to ourselves, but also others we encourage and talk to in the world. So that's our vision of what we're doing. So can we move to the next slide, please? Oops. Thank you. So for us, it's supporting the UK's wireless future. And our document is available on our website, and as just said, open to everybody. Our consultations are closed, and we'll issue our statement shortly. But actually, we'd like to engage, and I'll talk about some events at the end we're trying to do that in. So for us, it is actually, as I was key, supporting innovation, making sure we actually engage with people, we understand. Most businesses and most people don't understand spectrum. Actually, they don't care about it. It's that magic juice that makes things work, but they don't care. So they're not engaging with us. And often we can miss them because we don't talk to them, or we don't talk in the language they understand. So for us, we've been actually trying to reach out to people, talking to different sectors, understanding their needs, talking to them in a language that actually helps them talk to us, and a language that they understand what we're talking about. We're therefore being assistants, we're putting more information out. We're helping people, enable them to understand how they get access to spectrum. If there's inhibitors in our rules, what can we do about them? We're making more spectrum available for innovation, and we're actually doing it before long-term use becomes certain. So we're not waiting and saying to people, please tell me exactly what you want to do. We're actually making some spectrum bands available and actually understanding there might be things happening there, but put it out and let people do it. And as you may have seen, we did this in the 100 to 200 gigahertz band, but we've done this in other bands as well. We're also looking at new wireless technologies that are coming along and making sure those wireless technologies we understand and can fit within what we've got. And if they can't, what do we need to do to make sure they can? We are always very technology neutral, but actually when you look at the rules in the international arena, people do segment a lot, and therefore there's assumptions. So we want to make sure that when we're talking about these things, the assumptions that we've had don't make it there. We also want to make sure that people can access and the standards regime and make sure the standards are there to support them, not using standards as a way of inhibiting. The next phase we've got here is licensing fit for local and national services. Too often we've looked at either very, very local licenses, or we've looked at very, very large mobile licenses, which are nationally based. We know more and more people want to be able to use, as Martha said before, 3GPP technologies in different places. And we want to make sure that actually, if they want to do that in a particular place, whether it's in a business, whether it's in a business park, whether it's anywhere else, we've actually got the regimes in place that enable that to happen. And we give them licenses on the terms that are actually suitable for those sort of things. We are making a stronger push on promoting for sharing. And we're actually encouraging spectrum and encouraging people being good neighbours. We're encouraging this not just in what we are doing, but our engagements internationally and our engagement international bodies to actually look at the way things work to make sure that spectrum can be shared and people can access it and use it. So for us, it was putting the themes in place in a new strategy that enables us to think differently about what we're doing, challenge the way we've always done things, and make sure we've actually got a spectrum policy that's suitable for the next decade as opposed to it was suitable before. We also think in the international arena, when we talk about it, we also need to think about the future. Are we going fast enough? Does the regime we have in place help or hinder? Do we enable ourselves to be able to come up with rules at the time they're needed, as opposed to everything waiting for us to go through our processes? So there's lots of questions we need to ask ourselves as we move forward. And that's the sort of question we're trying to open and trying to talk about. So if we can move on to the next slide. And as I was talking about promoting spectrum sharing and encouraging people to be better neighbours, this is one of the things. Some people may have seen my slide before with large voices and big ears. And we're very much pushing on this sort of area. But one of us is making sure there is better data and sophisticated data in our analysis to actually understand what we're doing. If we go into meetings and we look at coexistence calculations, people take the worst case scenario on top of the worst case scenario on top of the worst case scenario, and then just a bit extra just in case. What we need to do is we want people to be able to share and be able to get better and closer together. We need to take more realistic assumptions. We need to understand how we protect what's there, but actually make sure we take realistic assumptions to make sure that we can fit things together. We also need to make wireless systems more resilient to your neighbours. So building stuff that was built 30, 40, 50 years ago on the set of assumptions, is it really suitable for tomorrow? How do we get people to improve the receivers they're using? How do we get people to improve their systems? How do we make sure that people perceive that they might get a noisier neighbor and actually build that sort of functionality in, whilst making sure we don't get rid of the economies and scale of scope of some of the things we're doing, but actually getting people to think about what they're trying to do. We want to get the efficient balance between what we do for protection and what we do for enabling. So how do we get these things right? We feel that this is somewhat of a change in what we're trying to do and where we're trying to get to. And therefore, we need to think again amongst ourselves about how we change it. We need to think also again how we engage with others to make sure we understand exactly what we're trying to do. And we're trying to help each other to make spectrum more efficient and effective. One of our primary duties is the efficient and effective use of spectrum. We're also putting some work much more into some of the stuff that more traditionally we've done in radio. So we're putting more effort into more propagation studies. The environment is changing, the noise floor is changing. We've got long-term projects looking at the noise floor. As the climate alters, effectively propagation changes as the climate changes. We're also looking at that, putting more effort into doing some more of that, more trials, more experiment, more field work, more analysis in our modeling, and we're building these analysis back into our work. So how do we get to those sort of things? How do we make sure this works for everybody? How do we make sure the technical conditions we put in place are the right technical conditions for today and for the future? So we get on. And if we can move to the next, please. As you would have seen, we have done and enabled more sharing and made more spectrum available. So we changed our framework about a year ago. There was a case for verticals, and verticals in mobile industry's case, it's absolutely every other industry sector apart from mobile, so it's everyone else. So we're not making spectrum available for particular industries, but what we recognize is that lots and lots of players want to be able to use spectrum at their locations for doing things. When people talked about 5G, they were talking about not just big wide area 5G or 5G provided by mobile, but some businesses wanted to provide their own networks, work with system integrators, have private networks in their places, or use a mobile network. For them, it depends how they do it. We don't want to interfere with the market, we want to enable. So what we made available is spectrum. We've auctioned spectrum for mobile for big national licenses, and we've just completed an auction of over the 700 megahertz band and the rest of the band. So we've now auctioned the entire 3.4 to 3.8 gigahertz band. But we also saw a need for people who wanted shared spectrum, and spectrum where they could use it at a particular location. And there we were giving licenses to people to actually use when they needed them. And these were exclusive licenses because actually in your business, you want protection from interference. You want to make sure that if your neighbor's got something, they're not causing you a problem as well. But we're also recognizing that businesses move and they change. So we want to put the flexibility in to enable that sort of thing to happen. So we made certain bands available for sharing, and we took bands which were actually mobile enabled. So we've taken some 1800 spectrum, some 2.3, 3.8 to 4.2 gigahertz band, which we spent a lot of time trying to encourage and drive the ecosystem by talking to the regulators. We've also taken parts of the 24 gigahertz band to enable that to be used as well, or the 26 gigahertz band, depending which part of the world you're in. And we put that as well to enable people to do it. We also made license exempt spectrum available, and I'll talk about the 6 gigahertz band available. But we think license exempt is also important because you want, as was just said, the ability to be able to use that ecosystem, to be able to deploy it everywhere, to not have to think about it, to build into all the millions of devices or billions of devices people do. So for us, it's making sure we have a framework that is fit for the future, that enables us to meet the needs of everybody who needs it, whether you need big national coverage and the ability to provide services wherever and whatever you want, and the ability to do business deals, the facility to have spectrum available at the point you need it for doing your business application, whether that's fixed wireless or whether that's in building for what people call industrial verticals or whatever else you want, or for people who want license exempt spectrum to make it available. So for us, it's making sure our frameworks and doing it. We continue to engage with all industry segments. And as I said before, we've been having workshops, we've been engaging. We're trying to increase the information available so people understand what spectrum is and understand if they need it for their business, that they can make it available for them. Because one of the biggest challenges for all of this is people not understanding what we're talking about. How do we make sure it's clearer to them? Not just to the experts, so how do we make sure it's clear to everybody to enable them to access these services and do it? We move to the next slide, please. Enabling growth in the 6 gigahertz band. 6 gigahertz is an interesting one. As we've just heard, lots of parts of the world have made the 1200 megahertz available for it. In the UK, we've made 500 megahertz available for Wi-Fi, in-building Wi-Fi and low power outdoors. And again, what we wanted to do was enable the growth of all these applications that are using it. Some of them, people just wanting faster and faster broadband and making sure that the Wi-Fi router is not the inhibitor to doing that by making more spectrum available in the 6 gigahertz band, wider channels, clear spectrum. We also did it outside as well at slightly lower power, 14 dB. And that was to enable people to sort of do these new applications, the very low power ones, the little things that the people are doing, things that no one quite knows yet, but people are talking about, enable those to happen wherever people go. So we were trying to put a framework in place that did it. At the WRC, people proposed that we should put in region 1 IMT in the upper part of the 6 gigahertz band. And we've been looking at this and saying, and we haven't yet come to a conclusion, but we know that it's a very busy band. For us in this band, there is lots of fixed links, microwave links, supporting very important services. It was also the place where actually some other bands we cleared down, which had low bandwidth fixed links, we were migrating into. So we got quite a number of fixed links in the band, and the diagram there gives you an indicative indication of some of the places where there's fixed links. And as you can see, it's quite all over the place, including in the North Sea. We've also got satellite, because this is another part of the C-band, and it's effectively the Earth to space, so the space receivers in it. We've also got some radio astronomy in the band. So we know in the WRC discussions, if you want to do IMT, there's going to be constraints on what you can do with IMT. The question is then whether those constraints allow it. We think actually the constraints won't allow you to do wide area mobile. But that doesn't say we couldn't take a policy decision to effectively make sure you could do wide area mobile and understand the implications of doing that. But we're also conscious that many businesses actually want to do different things with it. We can see a Wi-Fi based ecosystem developing. We can see the equipment therefore being available in this sort of band that people might want to use. So whilst we haven't taken a decision, we're also looking at other options in the band. And one of the other options we're looking at and consider is that some businesses tell us, yes, we'd like to use Wi-Fi, and the reason we weren't using Wi-Fi in our applications is effectively because there's the interference risk from our neighbor. So one of the things we've been looking at then is we could do indoor Wi-Fi in this sort of band without causing a problem to some of the other uses of it, so it could coexist. And our sharing framework, that would work. We could also say, actually, we don't want to constrain our future options for tomorrow, so we could put a licensed version in and therefore enable you to have, at the particular location you want, a license, but enable you to use the new Wi-Fi ecosystem or an IMT ecosystem, depending what you want and use in the band. Because we're technology neutral, you could use either and put the rules in place to do that. So for us, we're trying to make sure we look at all of the options, but we understand the consequences. But we also need to make sure that actually we're talking not just in a technical discussion about how you make things in, but making the policy decisions of what we want to do and making the right policy decision for the right bit of spectrum. We are doing a bit of work anyway, continuing to look at mobile demand. What is the mobile needs for the future? How do we satisfy that, and where do we satisfy it? We're also aware that we've got vast quantities of millimetric wave spectrum. So if you need capacity in mobile, you have to ask the question, what is the challenge you've got for tomorrow? And as others said, we've been looking at mid-band spectrum in various places. So for us, it's making sure we understand the needs of all the sectors, but actually make sure that we can use all of our policy tools to meet the needs of everybody, not just the needs of some. So we're looking at this and trying to make sure we can actually maximize the use of all the spectrum we have available. Because to be honest, almost every bit of spectrum below 100 gigs is already used by somebody. So how do we maximize the use? We move on to the next slide. For us, actually in the UK, we can do lots of things, but we think an awful lot of the stuff we need to think about in spectrum is global in nature. We need to engage in a global communication with everyone. We need to learn from others. We need to be able to share what we're doing, but actually see what other people are doing and see what we can learn from it. We don't want to do any constraints. So what we're trying to do is a number of engagements with people to try and do this. So here you'll see some issues we've got. We've got a wireless future global spectrum management challenges for the 2020s, and we're trying to have a debate, not just in the UK, but more globally with people to try and understand what's happening. The other thing we've been looking at is the terahertz bands. What should we do in the terahertz bands? Now, terahertz is very, very high frequencies, and people are talking about terahertz starting at 100 gigahertz, so 0.1 of a terahertz. But we're also looking at that. We shouldn't think about them in the same way as we thought about HF and UHF spectrum. How do we think differently? how do we make sure that when we open these new spectrum bands, we're opening them up for the future in the way they need to be done for the future, and we consider the needs of the future, not just do the same sort of stuff we've done in the past. So again, a discussion about, for us, looking at terahertz bands. And also we're then looking at future networks beyond 5G in the autumn. So people are talking about the new things. So what is the demand beyond it? These are the things for us where we want to engage in a global conversation with everybody to make sure we understand what's going on, to make sure we can learn from each other, and to make sure we set the agenda for all of us as we look forward, not look backward. So for me, spectrum policy is for the future, not necessarily the things we did in the past. Let's learn from the past, let's build on it, and let's build towards the future. Thank you very much indeed, and I'm very happy to answer any questions that people may have. Thank you.
Thank you very much, Philip. I really love the concept of developing resilience or better listeners in the spectrum ecosystem. I think that really resonates. We have one question from Don Means, and it's perhaps a two-part question. The first is, what impact do you think the emergence of these mega constellations of low Earth orbit broadband satellites is likely to have on the spectrum ecosystem? And the second is what sort of metrics are you looking for to drive these next generation policies? So, you know, a couple of easy ones.
Yeah, thank you very much. The first one's the easiest one of ever. I think the introduction of the mega constellations is quite a challenge. I think there's about 1,100 geostationary satellites in orbit at the moment, and there's more than that in some of the constellations that are going up in some of these new ones. They're all currently squeezing into the 28 gigahertz and the 14 gigahertz bands, essentially. And the question for us is, we had a regime that was very much based on a world of big geos, and also a world where people talk to each other in a certain way. You've now got new entrants coming in and trying to put these new systems in place. They've got to interwork with themselves and also that. I think for us, there is a conversation to have. There's already discussions going on at the ITU, but there's discussions we need to have with other people to see how we set the rules for the future to enable all these things to work and coexist. And I think we need to think about it as the new challenge, not just an increment on top of the old challenges. And I think this is going to be an interesting challenge for all of us of trying to get those things right. Because our rules were set in the days when there was a few. We've now got more. How do we make those rules work? How do we put things in place to enable everybody to be able to use the spectrum they need, the orbital slots and planes they need, but also when people have got services coming in our territories or on ships or on aircraft, that actually they can work in a way that we can overcome the problems very rapidly, as opposed to the bit. So I think it's an interesting challenge. The other bit on the matrix is quite interesting. One of the things we will put out when we do our statement is we'll put a new set of matrix out for one of the things we've done about what's been happening with spectrum, how spectrum is being used, and therefore looking at what's happening. We do an awful lot of work. One of my teams, actually spectrum policy and analysis, looks at what's going on, what's happened, what's happening in the future. They talk to all the industry players, they do analysis, they do calculations, and we use that. So for us, we'll be putting new data out to actually help. And again, we'll be happy to engage with people on those sort of things.
Thank you for very robust answers to tricky questions and for a great presentation. At this point, we turn now to our next keynote presenter from Saudi Arabia. Welcome Mohammed Al-Taibi, the Deputy Governor of Radio Spectrum for the Communication and Information Technology Commission. Over to you. You appear to be muted.
Sorry, thank you very much. Thank you very much for the introduction, Steve, and it's my pleasure. I'm very thankful for DSA, for you, for Martha as well, for inviting me to be part of this global event. I would start just my presentation, go into it quickly for saving the time. So here today we're going to share with you I would say the experience that we went through, the evolution that we went through in Saudi Arabia here over the last few years in order to enable more innovative use of spectrum and allow different users and different technologies to actually utilize this scarce resource. Next slide, please. Usually spectrum managers, usually they are part of the ICT regulator in many countries. However, the use of spectrum goes to aviation, to space, to defense, to security, to different other users in different sectors. So we wanted to make sure that we set up ourselves as a national spectrum manager that will allow the use of spectrum for everybody in the country. So we started by establishing or initiating a national spectrum strategy for Saudi Arabia, which from 2020 up to 2025. It was developed during the year 2019. And the main message of that there are different sectors that using the spectrum. Each one of them is like compose a pillar for within that strategy. One of them was for ICT and information and communication technologies and innovative use of spectrum. In order to implement this strategy, we had like very, I would say, a comprehensive implementation plan. Part of it was actually fostering innovative and commercial use of spectrum. We started as just Philip mentioned in his presentation that we wanted to listen actually to people, especially people, specialists and people who work in the industry. So we had to put about 80 pages, which is available on CITC website, of consultation, and we got very generous, about 66 responses from academia, government, mobile operator, vertical satellite operators, industry association, including Dynamic Spectrum Alliance and many other international companies. As everybody know, who's working in the spectrum domain, spectrum is a very international topic, so everybody who's engaged and what happened in country affect the others. So it was very engaging process. We learned a lot from that. Actually, we posed the question, we got a lot of answers and information. That's led that we are publishing all these answers. It's also about very thick document on CITC website, which I recommend everybody to read because it gives from different perspective, from different technology, mobile, Wi-Fi, satellite, and others, and our analysis of the current status and also the international trends. With that, we wanted to make sure when we are implementing our national spectrum strategy, we want to ensure that our spectrum, the way we manage spectrum, we stick to 3 values: transparency, so that everybody know what we are doing and how we are doing it, and predictability, so investors and people who actually develop technology can know for sure that this spectrum will use for what and for how long. We wanted to adapt, in general, we wanted to adapt an evidence-based, data-driven spectrum policy for the country. So based on that, we published our spectrum outlook for commercial and innovative use, which is actually, in summary, it was a 3 years plan from 2021 up to 2023 of how much spectrum that we will make available to innovative and commercial different use for different technologies, and the way we are going to go about it, the regime and the schemes that we will follow in order to make the spectrum available for different users and different technologies. Next slide, please. So in summary, what this document, the spectrum outlook, it led to an expansion of spectrum that can be made available for commercial and derivative use. Many of it, or part of it, was actually reallocated from legacy use, and some of it actually wasn't utilized before then. So we went into 3 different schemes. One of them, which is the exclusivity, the license spectrum, which about 4 gigahertz. We will go about it. We'll describe it later in the coming slides. License spectrum, we had, or we think, and we will explain it also as well, elaborate on it, we had to allocate about 6.2 gigahertz of license spectrum, which is, as Jessica mentioned, is historically, usually regulators, we go for more exclusive use and more kind of giving the right or selling the rights to use that spectrum to specific users. However, we think, and based on data that we received from different industries, different players, different technology, all the work that we've done, that we need to expand the license spectrum massively. The third regime, which is in between the hybrid, was the lightly licensed spectrum, which is more than 13 gigahertz, and also in the next few slides I'll be explaining that. In total, the spectrum outlook was making an expansion of 23 gigahertz of spectrum that available for commercial to use within the country. Next slide, please. So I would start with the license exempt spectrum, because this is probably the essence of allowing sharing spectrum between different users and different technologies within bands instead of this exclusive rights. We allocated about 2.0 gigahertz that across the 6 gigahertz in the 70 gigahertz, and then also part of it for the 5.9 gigahertz for intelligent transportation systems. We are now running through different consultation, updating the different policy in order to make that spectrum. We made that decision, but we are working on how that will be available and used. So we followed, actually, there was maybe 2 prominent models at that time when we were looking at the benchmark, the best practices between Ofcom and FCC. FCC was going with the full band, as Jessica explained, the 1200 megahertz, while Ofcom went with part of that band. For both, actually, both options was feasible. However, based on the that received, based on the different analysis that we run, based on a lot of statistics, we thought that it's the best for the country to allow the whole band usable for a licensed technology, mainly Wi-Fi, but not exclusively to Wi-Fi, of course. It's for a licensed exempt use, and we think this is the way to go to meet this, I would say, increased demand on wireless connectivity. We think that smart technologies that can coexist, that can actually co-use or use the band in a sharing manner, will be the technologies that will allow sustainable improvement and growth for different wireless technologies. Also, we are working on publishing the rules and regulation for using that band, also as well as the 66 up to 71 gigahertz band. We are also as well consulting with the different manufacturer, with the people who are actually driving the use for the 5.9 gigahertz. And we will be consulting by early next year. However, now we are doing trials with some of our partners like Qualcomm's and other manufacturers. In general, before I leave the slide, one thing is that we thought, and that there was a lot of debate between, I would say, IMT industry and the license exempt industry. We've heard there was a lot of filing, a lot of opinions, which all respected. However, we think that we are already kind of making enough exclusive spectrum on exclusive basis. However, we could or we think that license exempt technology will need to be big, need to have a big stake of the future of allocating the spectrum, because as more demand is being in order to address a lot of demand that we are going through, we need to make sure that we are making a smart I would say availability for spectrum for different technologies. Next slide, please. So, as you know, probably Saudi Arabia has already took kind of a leadership in 5G. We are almost in every ranking. We are in the top 5 countries, thanks to the more than about 600 megahertz of spectrum that's been utilized today in Saudi Arabia in different IMT bands for 5G. We think this can go hand in hand with actually also allowing license exempt use. Within the spectrum outlook, which I'll explain later, there is a lot of more than about 900 megahertz in the mid band that will be made, that has been and will be made available for IMT and 5G technology. So we thought that giving a big chunk of the mid band for license technology is a necessary step in order to allow this complementarity between technology, in order to allow fair access for all technologies, that they will actually complement each other and need each other in order to provide the best services to the end users. As you know, this is just a kind of a snapshot on what's been going. There are different countries, including Saudi Arabia, United States, South Korea, and many other countries in Latin America that we are adapting the whole band for 6 GHz. Some of them actually adapted part of it, like UK and the United Arab Emirates, and also the European Union. We think there is no right or wrong in both options. It depends on each country. However, we think that license exempt in the mid-band is necessary. In the case of Saudi Arabia, we already made a good amount of spectrum, mid-band spectrum, to the 5G. So this was kind of the right step to take in order to make sure that we allow fair access for different technology and different uses. Next slide, please. Also, as I mentioned in my first slide, we are adapting the lightly licensed spectrum regime. We are now going to consult about it by the end of this month. We made available different bands while actually working to protect the primary user. As Jessica explained in her presentation, there are always primary users. In this case, in many of the cases, was satellites, fixed links, or other users. We are trying not to put limitation on their growth or their usage of that spectrum. However, we want to increase the utilization of the spectrum to allow different other technology that's smart enough to listen before it talks and have access, smart access to the spectrum. This is how can innovation within wireless industry can be built. If we allow them smartly, that they can utilize smart technologies in order not to cause any harm or interference. However, they can have access to the spectrum and develop different use cases for the end users. There are different regime that we're looking at, and we are going to consult about it, including the databases where we create actually distributed databases for users to access in different geographic location, and based on that they can decide which channel they can use without actually harming the primary users. This is also will open up the commercial government spectrum sharing. There are many in each country. There are many bands that utilized for national reasons by the government. However, we think there is unexplored option of sharing the spectrum that being exclusively assigned to this usage without causing any interference or jeopardizing any of their sensitive use. Next slide, please. So also we opened 2 bands. Actually, there was, and the reason for that, there were 2 reasons. One was there's no much demand on these bands by any specific industry or specific users. Also, we think that trials, in order to develop innovation, we need to open bands for trials and for testing by different users, by academia, by people who develop technologies, by also those who are skeptical, unsure of this technology will resonate with the user, so they can actually make some trials, which we call the trial licenses, in order to see does that is there going to be a demand will be created when we offer that technology without having to go through a massive scale or deployment and then not probably ending up using that spectrum. So we try to open that. We think these test and trial licenses will help the research and development, will help actually developing and innovating in different technology without having to pay a lot of fees for using that spectrum, and give the chance for this technology to grow organically. Next slide, please. Yeah, so I will, this is probably maybe not the last slide, but the one before. So I will end up with actually the license spectrum. We are trying to, we don't think here in CITC that we have to go in one model for every band and every spectrum. So there is no way that all spectrum will be license exempt or lightly licensed or licensed. We had to actually, based on the case, to tailor the way that we manage the spectrum and or make it available for the users. there are some, especially the mobile industry, there are a need in order to allow the investment, there are a need for exclusivity to access that spectrum, which we recognize and we respond by allowing or making multiple band, the 600, the 700, 3.8 till 4 gigahertz, and the 2.1, the extension, and also the 1500, as well as the millimetric wave in the 26 gigahertz band. We are planning to auction this spectrum bands over the next 3 years, as you can see in the timeline, as well as having access to different technologies and different group of users like the industrial sector to ensure that they actually have or utilize that spectrum. If we go to the next slide, please. So this will be my last slide. So we are trying to actually, by the end of this year, we are already consulting about it. We just opened the consultation last week, and it's available in the link that you can see, which is a consultation document about the next multi-band spectrum auction that we plan to do by the end of this year in December. We think that there are, even when auctioning spectrum, even when selling the exclusive right to use that spectrum, we think that different technologies, they can form consortium, or they can come together and make sure that when they apply or bid for spectrum, they allow both terrestrial and non-terrestrial component to coexist. They allow different users, they allow the industrial users to have their needs for digitizing the industrial sector and enabling the industry 4.0. We are trying to look at a comprehensive or holistic design for that auction in order to embed it within that auction a way that different users, different technologies, different even players can coexist in using that spectrum if they coordinate enough between them and actually collectively have that exclusive access. This is a sort of a way we are enabling them to invest and ensure that they will have that spectrum locked for their use for a long time, for 15 years or so. At the same time, we are allowing different technologies and maybe even setting some obligation to make sure that these technologies are being adapted for the benefits of country. As you can see in the figure shown in the slide, there are different technology for different uses. Some of them, they could work in the rural areas, while others only work in the urban areas. We don't think that the way to go in the future to go with one singularity or one kind of technology, terrestrial, for example, technology. We think a different array or multiple kinds of technology need to coexist and need to be developed. This will only happen in collaboration between the regulator, between the technology manufacturer and vendors, also and developers, as well as between the operators. We think this wireless revolution that we are going through needs a lot of response from the spectrum manager, from the spectrum policymaker. I think we are trying here, as you can see from my colleagues in the first two presentations, we are trying our best as a spectrum managers to manage that this scarce resource efficiently in order to allow all these technologies. The technology needs to learn how to exist, to allow sharing. With this, I conclude my presentation, and thank you very much.
Thank you very much. I think that's such a wonderful message, that there is no one size fits all to spectrum regulation, and that regulations require, regulators require, as extensive a toolbox as possible to address these issues. So we turn now to the African continent, and our next speaker is a veteran of the Communications Authority of Kenya, and is now coordinating spectrum regulation among regulators on the continent. Welcome, John Omo, Secretary General of the African Telecommunications Union. Oh, we can't hear you, John.
Hello, can you hear me?
Perfect.
Yeah, I guess I'm gonna, yeah, fortunately, light is come back. I got into some partial darkness. Thank you very much, Steve, for the intro, and certainly my thanks to the Dynamic Spectrum team for inviting me again to speak this year at the 9th Summit. Certainly, it is great to be amongst colleagues, regulators, governments, policymakers, the private sector, and even the civil society to discuss such an important topic. I will be very brief. I was asked to speak about what the ATU has done in terms of the 6 gigahertz, and so that's what I will confine myself to. Most of you now know, I believe, that we are a specialized institution of the African Union in the realm of ICTs and telecoms development. We've been around since 1977 under, different names. A membership-driven organization, so that we have about 48 or so member states from Africa. About 5 of them are still not our members, and we have over 54 now, I believe 56 rather, of associates, private sector organizations, civil societies, and international organizations being our associates that operate in Africa with a core mandate, being to accelerate the development of telecommunications and ICTs in Africa. For purposes of achieving digital economies. Now, in the area of radio communications, we have been focusing largely on development of recommendations, handbooks, reports, and strategies for coordinating radio communications management and development in Africa. And so much of our work, a fairly lean secretariat, so much of our work is largely membership driven through, task groups and teams that we work with. Steve, if you'd allow me to just turn my video off, I hope the audience won't mind, because sorry about this. Now, recently, we commissioned a task group on emerging technologies, whose mandate included inter alia exploring wireless in the 6 gigahertz and also 60 to 70 gigahertz bands. The result of that assignment remains outstanding and sometimes quite thought-provoking. And this is the background to it. With the advent of COVID-19, the African Union ICT Ministerial Bureau met and considered strategies that various African Union organizations could take in order to mitigate the adverse effects of COVID-19. That was in April, May 2020. And so they approved an action plan in the ICT sector for purposes of assisting, working in order to assist various African governments respond to COVID-19 by, harnessing the potential of emerging technologies. And that's where we came in. As I mentioned, we formed a task group comprising of the membership. And the membership here comprises, the member states and the associates, as I mentioned, the private sector, the civil society organizations with which we work. And they've developed a raft of recommendations in this area. Let me just highlight some of the key elements of the recommendations. So in order to foster a harmonized, the aim is to foster a harmonized use of the band 57 rather, to 66 gigahertz by wireless access systems and radio local area networks on a license exempt basis in Africa. And the draft recommendations include, amongst other things, which we do hope, as I'll mention briefly, our membership should be able to adopt. Now, the first of this is designation of the frequency band 5925 to 6425 megahertz for use by WAS and R-LAN equipment restricted to very low power, both outdoor and indoor use, and low power indoor use only on non-exclusive and non-interference and non-protected basis. So it's non-exclusive, non-interference, and non-protected basis. The range here is limited to the lower 6 gigahertz as the upper portion is part of the WRC 23 agenda, and so we've left that out in our recommendation. The second recommendation is the adoption of prescribed technical and operating conditions and allow all compliant technologies when implementing WAS and R-LAN in the frequency band 5926 to 6425 megahertz. Thirdly is to exempt WAS and R-LAN equipment that comply with the prescribed technical details from individual licensing. So that equipment, our recommendation to the regulators in Africa is that they should not be individually licensed. And fourth is the consideration of authorizing any WAS and R-LAN systems that operate in the frequency band 5925 to 6425 megahertz and comply with the prescribed operating conditions. So the fifth is ensure that WAS and R-LAN equipment and devices comply with the technical and prescribed operating conditions in the member states. And lastly is to allow free and if you wish, seamless cross-border circulation and use of WAS and R-LAN equipment devices that comply with the prescribed technical and operating conditions. Africa comprises of several countries, and some countries are big, others are very small. So we do hope that the synchronization of the prescribed operating conditions will then facilitate, free and cross-border circulation of the use of this technology. Now, the key points to note from these recommendations, maybe 4 or 5 of them, is that the Wi-Fi 6 gigahertz being an emergency technology means that being an emerging technology means that very few of our African countries have implemented the technology on a large scale in the past, and therefore we do hope that these recommendations will serve as a good starting point for the implementation of the use of this technology. The second point is that we need to work on a system of monitoring and evaluation of the implementation of these recommendations. And so we deem that the task team that has worked with the membership in the development of these recommendations will then have the mandate to, work with the membership in order to see how well the membership, especially the member states for that matter, adopt and implement the recommendations. And as part of that endeavor, we do hope that we'll work on an awareness creation strategy amongst the various stakeholders and publish reports on the recommendation, on the implementation of these recommendations. And then in terms of review of these very recommendations, we think that technology being fairly dynamic, we should be able to review their applicability on a regular basis. But certainly, after every WRC, we will seek to, look back and see how well the implementation is going on, and if there's need for review, we'll undertake that. Now, the hope is that this has largely involved, the private sector that operates in Africa. They've been part and parcel of the process of development of these recommendations. And so we do hope to build on, as was said earlier, economies of scale, since the use will be harmonized across the continent. So we hope to build not just economies of scale, but interoperability of systems across the continent. And the impact of these recommendations, much of Africa is still rural, with large numbers of population being based in the rural areas. So we do hope that the adaptability and implementation of these recommendations will see not just a harmonized implementation of this, but facilitate, reach in terms of affordability, in terms of quality, and in terms of physical reach, in terms of connectivity in the hitherto hard to cover areas in Africa. So as I've mentioned, we've left the higher bands of this outside the scope, and we do hope that in our preparations for WRC, we will consider this in our debates and in our preparations. I think the key question that one would ask, Africa being 55 or so member states, how are we going to ensure implementation of these recommendations? Again, as I've mentioned, much of the effort that went into this was membership driven, through member states and the private sector that operates in Africa. And so there's some force of reason behind the recommendations. And so we do hope that whereas, the members, especially member states, have the sovereign right to consider or pick and choose what to implement and what not to implement, we do think that the force of reason, given they have themselves been part and parcel of this very process, will ensure a smooth implementation. And we do hope to publish, as part of monitoring the adaptability of these recommendations by the membership, that that publication will also see not really force or put some members in bad light, but the force of reason in terms of their participation in their development, and to see that there is a periodic publication of member states that have adopted them, will ensure the widespread reach and implementation of these recommendations. Now, the recommendations are out now, and we've sent them to the member states for their comments. So far, it looks like the feedback we get is positive, that the members agree to implement this, and so we do hope to have a validation workshop sometimes in July, sometimes in mid-July, in order for the membership to adopt this. And so we think that there will be widespread implementation of this in Africa, and that will give us a positive outlook and to catch up with the rest of the world where these are being implemented. We are also working on a couple of other issues in the radio sector as a union, and we've developed a set of recommendations on spectrum audit, spectrum licensing, spectrum evolution, and spectrum management fundamentals. And we do hope that or rather, these were launched in April, and the membership have already started implementing the same. We are also working on the edition of the African Spectrum Allocation Plan. You know, each of our countries have their individual plans, and given the miniature nature of some of the countries in Africa and others are large, there's need for a harmonized spectrum allocation plan. And so we're working on this with the membership currently, and the first draft is already being out there for review by the membership. We are also working on a satellite resources strategy for Africa in terms of acquisition, retention, and use of satellite resources, and we do hope to publish a handbook on the same once the membership will have you know, given their nod to these guidelines. Lastly, or certainly by no means last, as I've mentioned, Africa comprises of large swaths of, you know, rural population, and so we're working on a strategy for use of spectrum for rural connectivity with the membership, and so we do hope that these guidelines, again being membership driven, will be adopted by the member states in such a way as to, you know, ensure a standard applicability of the guidelines in terms of spectrum use for purposes of ensuring rural connectivity. So we do look forward to you know, the adaptability of the recommendations, and it is our hope that this global summit will help everyone that is involved in this very process. DSA has been part of us. Will keep the enthusiasm alive in terms of spectrum, you know, dynamics spectrum sharing methods and models, and as we debate, we do hope to share these experiences and also, you know, work with colleagues, share views and experiences with colleagues in terms of what can truly work for Africa. Sorry, I've not been as detailed as the colleagues that spoke earlier before me, but I do hope that we can get some debate out of this presentation. Thank you very much. Over to you, Steve.
Thank you very much, John. You know, ATU plays such a critical role in you know, facilitating coordination among African regulators and enabling the voices of African regulators who face challenges that may be different from other regions. So, and coordinating the voices of nearly 50 members is a daunting task. So kudos to you. And we have one question for you from the audience, and it's from Toby Ewell, Policy Tracker, and it is: do you see a role for TV White Space to be part of the Africa-wide strategy for rural connectivity? And if so, do you see ATU also monitoring the implementation or encouraging its adoption?
Thank you very much for the question. Can you hear me?
Loud and clear.
Thank you very much for the question. Indeed, quite a number of African countries, especially I think within the SADC region, are working in the and have already conducted trials on the TV white space. So we as a union still don't have, you know, a common approach to this. The use of this resource, but it's something that we would encourage adoption of, and we do hope to, you know, explore some work, especially with the membership that are already undertaking, already you know, implementing you know, the use of this resource in their countries. So we hope to work with them for purposes of encouraging this technology. It is not one of those that we've come as a union to, you know, have a harmonized view on, based on the different experiences in different countries in Africa. But indeed, there are countries in Africa that are already experimenting. Some indeed have already gone on trials with this technology. Thank you very much.
Thank you, John. And that question actually provides a great segue to our next speaker from Kenya. Kenya is a pioneer, not just in TV white space technologies, having undertaken the first trials as far back as 2013, but also in the release of digital dividend spectrum, putting Kenya at the forefront of access on the continent. So I'd like to introduce now Tom Uwero, Director of Frequency Spectrum Management at the Communications Authority of Kenya. Welcome, Tom. Tom, can you hear me? All right, we seem to have a problem with. Oh, there we are. Fantastic. Can you hear me, Tom? Oh, we can't hear you. You seem to be muted. Still not hearing you. Try again. Hello? Okay, we'll wait just another minute.
We can see his video, but not his voice. Tom, can you hear me? Can you just raise your hand if you're hearing me? Just raise your hand if you're hearing me. Okay, towards the right corner, you'll see. Tom is out of town. I don't know whether that. Are you there? Okay. Do you see the speaker? We can't hear you still, Tom. Oh, that's sad.
I think while we're waiting to sort out Tom's audio connection, Philip, there were if you're still there was a question for you that we didn't get time to get to. Are you still there, Philip? Sorry, we seem to have lost Philip as well. Okay, well, I think we have to move on to the next session, and we will try and bring Tom back at a later stage, if that's all right. We'll just wait one more minute to see if we can sort that out. No, it doesn't. It doesn't seem to be resolving itself. Okay. Well, our next session is on spectrum sharing in the midband in North America and Europe. And to moderate and lead that session, we have Michael Calabrese, a pioneer in thinking on spectrum sharing, and the director of the Wireless Future Program at the Open Technology Institute at the New America Foundation. Welcome, Michael, and over to you. Michael, are you there?
Yeah, can you hear me?
Great.
Sorry, I thought I needed to stay off until the other session was completely done, so here I am.
Great, thank you. Over to you.
Okay, well, thanks very much. Hold on, I'm just trying to get the controls here working. All right, so welcome to this summit session focusing on developments in spectrum sharing in the midband. Globally, the midbands between roughly 2.5 gigahertz and 7.5 gigahertz have become the most valuable and sought after spectrum for both 5G and next-gen Wi-Fi operators. A perhaps oversimple but apt analogy is Goldilocks porridge. For the 5G ecosystem and for emerging IoT applications, midband spectrum combines good enough propagation for coverage with the wide channels necessary for gigabit throughput and low latency. In the US, as we heard earlier from Acting Chairwoman Rosenworcel, over the past year, we've seen historic developments in the 3 gigahertz and 6 gigahertz bands in particular. For the exclusive licensing useful for national or regional cellular networks, the 3.7 gigahertz auction that concluded in January in the US generated $81 billion in net proceeds for 280 megahertz, although 90% of it came from the 3 largest mobile carriers. Advocates of next-gen Wi-Fi 6 gained access to a whopping 1,200 megahertz of new unlicensed access across the entire 6 gigahertz band, including 850 megahertz for outdoor and full power deployments subject to automated frequency coordination. And for those who prefer a hybrid approach that provides spectrum directly to smaller and local non-traditional providers, the CBRS 3-tier sharing framework at 3.5 gigahertz launched in a big way, including an auction last summer that featured a record number of bidders and winners, 280 winning bidders, including utilities, universities, and cable companies entering the mobile market. Our panel includes 4 individuals who have played a leading role in shaping the innovations around midband spectrum sharing. They will each give a brief overview of developments in midband spectrum, and then we'll have a discussion and answer your questions. So as we go along, please put any questions into the chat, and we'll try to get to as many as possible. So let's move on in order. We'll hear from Andy Clegg, then Dave Wright, Chuck Lukaszewski, and Jennifer McCarthy. And first up is Andy Clegg, who is the spectrum engineering lead at Google. Andy?
Hey, thanks, Michael. Can you hear me okay?
Yes.
Okay, great. So thanks, everybody, and thanks for having me at the DSA Global Summit. I'm going to kick off with just sort of a very high-level overview of the 3 gigahertz landscape in the United States. And then some of the following talks will deal a little bit more detail with particular parts of 3 gigahertz, and also some 6 gigahertz comments, and then also some look at the international part of this. So if I could kind of summarize the 3 gigahertz landscape in one slide. If you want to move to the next slide, please, Josh. In the US, 3 gigahertz is complicated. It's more complicated than it is in most other areas. And so that's why we have a lot of dynamic spectrum sharing arrangements, either already implemented in 3 gigahertz or planned for 3 gigahertz, potentially in the future. So why is it complicated? Okay, if we go to the next slide. It's complicated because we have a lot of encumbrances in the United States in the 3 gigahertz band compared to others. So I've taken a broad view in this spectrum plot. I'm looking from 2.9 gigahertz down at the lower end up to 4.4 gigahertz at the upper end. The biggest encumbrance that is a challenge for us in the United States is that our own military, the Department of Defense, or DoD, is very heavily invested in the 3 gigahertz region. It's used significantly for radar operations, land, sea, and air, basically all the way from 2.9 gigahertz all the way up to 3.7 gigahertz. That whole range is used one way or another for radar operations by our Department of Defense. And these are major systems. These are on aircraft carriers, for example. These are on current generation destroyers. They're on next generation aircraft carriers and next generation destroyers and cruisers. They're on airborne systems, which of course from a spectrum sharing perspective is always a challenge. And they're also on land-based systems in some areas around the country. So it's a significant encumbrance that we're having to work around in 3 gigahertz, and it's one of the reasons why the use of 3 gigahertz in the United States for 5G is a little bit more challenging than it is in other countries. So besides the DoD operations in below 3.7 gigahertz, we also have a significant encumbrance above 3.7 gigahertz. We have a lot of receive-only fixed satellite service earth stations that operate in the 3.7 to 4.2 gigahertz band. And in fact, in a relatively recent count, we have about 18,000 fixed satellite service dishes around the country that are registered in the FCC database that need to be worked around. So it's another significant encumbrance. And down at the bottom, you see the fixed service links there. So we do have a few fixed service links in the band, but not nearly as many as we have the fixed satellite service. So the next slide, please. Next slide, please. Okay, good. So so the 3 gigahertz band, although it's heavily encumbered, actually is a very important part of the US 5G strategy. So we're having to work around the encumbrances and find ways to make everything work, potentially by sharing spectrum or relocating. So I put on this chart basically the same spectrum band chart that was on the previous plot, but up there in purple are overlaid the 4G LTE and 5G NR 3GPP bands. So you notice that there is a lot of opportunities for 5G in N78 and N77 in the 3 gigahertz band that other countries and other regions are taking advantage of. And that's also what we want to try to start taking advantage of in the United States. Around the world, 5G is being deployed in this band range. So for example, CEPT is under a mandate to make 3.4 to 3.8 gigahertz the first primary band for 5G. So we've taken a step. The US is currently sharing part of the 3 gigahertz band for broadband services, and that's the Citizens Broadband Radio Service slice that's shown there in green. And that Dave Wright will be talking about that CBRS in much greater detail shortly. But we're also very active at clearing or sharing additional segments of the 3 gigahertz band. So we had a couple of congressional acts that effectively mandate the use of 3 gigahertz, the clearing of 3 gigahertz, or the sharing of 3 gigahertz for 5G services, and that's what we're in the process of implementing right now. Are those actions under the Mobile Now Act passed in 2018, 2019 and the Be China Act passed in 2020. So next slide, please. So this is the near-term evolution in the 3 gigahertz band. So what the band is up today, and then the second chart, the second bar down is what the band will be shortly. So the first thing you notice is that we are reducing the use of the 3.7 to 4.2 portion for fixed satellite service, and we're reallocating, we're clearing part of that band for what we call the 3.7 gigahertz service flexible use, which is essentially 5G. When the US uses the term flexible use, it generally is the term that's used to support 5G services. So we are refarming, repacking the fixed satellite service into the upper part of their band, reallocating the lower part to the 3.7 gigahertz service. And then finally, we've also adopted plans to take a sliver of spectrum from 3450 to 3550 and also adopt it for flexible use. That's the 3.45 gigahertz service. And those two services, those two new services, flank CBRS there in the middle. And what I've noted is that so 3.7 gigahertz service is exclusive use. Those operators that bought that spectrum, and Michael referred to it earlier, they get exclusive access to that. They don't have to share it with anybody. Whereas the 3.45 gigahertz and the CBRS services are shared. I'll talk a little bit more about that in a minute. Next slide, please. So the 3.7 gigahertz service, so this is unshared. This is 3.7 to 3.98 gigahertz. As mentioned previously, we're relocating the 18,000 fixed satellite service dishes out of that band and also reconfiguring satellites so that in the United States, they don't need to use that band. The flexible use allocation will run from 3.7 to 3.98 gigahertz. We auctioned that spectrum from December 2020 to January 2021, generated $81 billion in net revenue, which is the biggest auction haul ever, which is good or bad, depending on your point of view on these things. And those carriers will also have to pay for about $13 billion to clear the satellite services out. 78 billion of that 81 billion came from just 3 traditional carriers. So this is obviously a big carrier band. The 3.7 gigahertz service will operate only in the contiguous United States. It won't operate, for example, in Puerto Rico or Hawaii or Alaska. And those licenses will be on a partial economic area basis and last for 15 years. There will be sort of 2 clearing tranches in 3.7 gigahertz. The first should be completed by December 5th of this year. That's the lower 120 megahertz of the band. And then 2 years later, December 5th of 2023, the rest of the band will be cleared and we'll have full 3.7 gigahertz service. The EIRP limits are quite high, as much as 3,280 watts per megahertz in this band. So it's going to, it will support very high power services, macro services, if so desired. The reason I put the radio altimeters in the spectrum plots on the previous pages is they're concerned that these high power systems going up to 3.98 might cause interference to aeronautical radar altimeters in 4.2 to 4.4. That's an issue that's being worked in industry, but hopefully that doesn't become a problem. Next slide, please. So the 3.45 gigahertz service, so this is 3450 to 3550, will be auctioned later this year, coming up in October. Some of the DoD systems, some of the radar systems that I had previously identified that operate below 3550 are going to stay in that band indefinitely. A lot of them will be cleared, and that clearing may take as long as 11 years. But some systems will remain indefinitely in that band. And our DoD and our federal spectrum regulators have a plan for how the commercial operators in 3.45 to 3.55 will continue to operate. They've designated 33 areas, what we call cooperative planning areas, around the country where the DoD will continue to operate, and then the 3.45 gigahertz service operators will have to coordinate with DoD in those areas. And then dynamically, 23 of those 33 cooperative planning areas are also considered periodic use areas where even more intensive use by the DoD may occur on occasion. And there will have to be additional sharing arrangements made then. And it's not quite yet determined how that dynamic sharing will work, but it's under discussion in the government and with industry of how that will work. The technical rules adopted for 3.45 to 3.55 were virtually identical to the ones adopted for 3.7, so very high power services. It's also being licensed in the same way. It's licensed in the contiguous United States on partial economic area basis, 15-year term. And initially, you'll only be able to get 40 megahertz in any given license area. But that restriction expires after 4 years. So 3.45 gigahertz will be an interesting development. If you go to the next slide, please, a really quick plot of the cooperative planning areas and the periodic use areas. As you can see, they're sort of clustered along the coast, which is also tends to be where our population is. So these are not minor areas. There will have to be considerable attention paid to how the coordination is going to work so that it doesn't interrupt too much of the population. Next slide, please. So how do we see the future of the 3 gigahertz band evolving? So the top is what it is today. The next one down is the one I already showed. This is in progress. These are auctions that have either already occurred or will occur later this year. What's going to happen next? Well, the government is under mandate to also look at what can be done with 3.1 to 3.45 gigahertz, which is the rest of that DoD radar band. So they're looking at what the sharing opportunities or relocation opportunities are there. And in the far future, this is a bit of my own prediction, not really anything that's established in any official way, but it'll be interesting to see whether the 3.45 gigahertz band continues to be shared with DoD or whether they're able to clear completely out of that band. And also, I'm wondering what the long-term prognosis is for any fixed satellite services in 3.7 to 4.2. It could be that they completely transition out of that band and that 3.7 gigahertz service, or perhaps another service, would then expand into the 4,000 to 4,200 region. But again, this is just a guess. This is nothing official. This is sort of what I think see the thing transpiring. And then next slide. So our, the US 3.5 band has a very complex set of encumbrances, but also because of the way the 3GPP bands are designed and what's going on in other countries, it's highly desirable for deployment of 5G systems. So that's what we're working on. The DoD, NTI, FCC, and industry have been working together very well in the last few years and continuing on to make now what totals 530 megahertz of contiguous spectrum. But 47% of that, 250 megahertz of it, is shared spectrum. So we've designed systems to find ways to share that spectrum with ongoing DoD radar operations. What's going to happen before 3450 for more spectrum is TBD, but it's likely going to require sharing as well. And also the long-term disposition of that upper part of the 3.7 gigahertz band with fixed satellite service is also TBD. So something to look for the long term. So that's it, Michael. Thank you. Back over to you.
All right. Thank you, Andy. That was very comprehensive and helpful, especially to see those visuals. So next we have Dave Wright, who is president of the OnGo Alliance, and also the new head of global wireless policy at Hewlett Packard Enterprise. Dave?
Thank you, Michael, and thank you, Martha, and the Dynamic Spectrum Alliance for the opportunity to speak here at the summit. As Michael pointed out, I'm speaking here today on behalf of the OnGo Alliance. As of last week, I have joined Hewlett Packard Enterprise, so my colleague Chuck is up next, but I'm not speaking in an HPE context here. This will be OnGo Alliance. So next slide, please. I think we've heard a number of references already to the CBRS framework. Acting Chairwoman Rosenworcel talked about it as an example of really how policy managers, policymakers, regulators can move beyond a binary choice between traditionally licensed and traditionally unlicensed spectrum. And I love that view. I've made that same point myself, that this is a new tool in the toolkit for regulators. Andy just talked about the federal incumbent systems that we're protecting. Michael mentioned this is a 3-tier framework. So at tier 1, we do have those incumbents that we continue to protect, but we're introducing 2 new tiers of commercial service. And that's the priority access layer at tier 2, which is really analogous to protected exclusive use spectrum, much more familiar to people who've dealt with licensed spectrum historically. And then at tier 3, we're introducing essentially opportunistic access at the general authorized tier or GAA tier. And at a very simple level, any spectrum in a particular location that's not being utilized by an incumbent at tier 1 or by a license holder at tier 2 becomes available for general authorized use. And so it really is a very dynamic, a very flexible model. I mean, I can't think of a spectrum management framework that's better suited for, an organization like the Dynamic Spectrum Alliance than CBRS. A few things I'd point out. I think Andy was talking about licensing terms in the 3.45 service. So here at the PAL tier, and we've heard a little bit about the auction already, which I'll touch on. But we did have an auction of the PAL licenses last August timeframe. Those were sold at the county level geographically. They were sold for 10-year terms, and there were some prohibitions about how many you could buy. So no single entity could obtain more than 4 of the PAL licenses, and each license is 10 megahertz wide. So only up to 70 megahertz of the overall 150 can be allocated for PAL in a county. Any one entity was limited to 40. And then there's also some robust, I would say, incentives in the rules that really encourage an active and robust secondary market. So we expect that unused PAL rights, license holder buys it, their plans are very localized within that county. We think they'll be absolutely incented to make those unused rights within that county available to other people who might want to essentially lease the spectrum or lease those protected rights on a short-term basis or in a more localized area. So that was on PAL GAA. The way that all of this is happening, again, kind of coming back to the dynamic piece, is via geolocation database coordination. So the FCC and Commissioner Rosenworcel talked about this. Pardon me, Acting Chairwoman Rosenworcel talked about this. The FCC, I think, very forward-thinking, decided to let industry supply this database coordination component to the system. So we now have a number of companies that have stood up commercial spectrum access systems. Every radio, every CBRS radio, whether at the PAL or the GAA tier, will talk to those SASs, register into them, provide the relevant information that's needed to operate, and then get a spectrum grant. So the SAS actually is aware of the spectrum environment at that location, is aware of whether it's a PAL or a GAA radio, or whether the grant is for a PAL or GAA piece of spectrum, and then makes the appropriate spectrum allocation decision. So this is really the beauty of CBRS, is the database coordination. There's another system called the ESC, which is partly how we help protect the federal incumbents, but that's probably a little in the weeds for this conversation. Andy talked about some of the new power levels that we're seeing with the other 3 gigahertz services, such as the 3.7 and 3.45 services, up to 3,200 watts per megahertz. CBRS is a much lower power system because of the incumbent protection requirements. So there's essentially 2 categories of radio. Category A, which you can conceptualize as essentially small cell indoor, up to 1 watts of radiated power per 10 megahertz. And then the category B, which is a metro cell, picocell type of implementation. These are outdoor, up to 50 watts per 10 megahertz of radiated power. And Andy kind of showed this on one of his charts, but I thought it was important down at the bottom just to highlight the fact that we're really benefiting from the fact that the CBRS band lays neatly on top of bands that have been defined for some time for both 4G LTE, band 42, 43, as well as 5G new radio, so N77 and N78. And when I talk about some of the hardware ecosystem that has formed around the CBRS opportunity, a lot of that momentum that we've seen is directly attributable to this alignment. So to, the folks who are looking at allocation decisions, I just want to point out, when you can align or overlap with activity that's going on in other markets around the world, it really does help industry and the market to form much more quickly. And that's certainly what we have seen with CBRS. Next slide, please. Because of this, the dynamic framework, the ability to support both the exclusive as well as the opportunistic use cases, what we've seen is just a tremendous response from industry. And I think it was Philip Marnick in his presentation talked about, from a mobile operator or maybe 3GPP perspective, anything that's not mobile operator is verticals. And so I guess in this case, or in this slide, what I would say is the second block, mobile capacity augmentation, that is the mobile operators using CBRS to add capacity to their networks, particularly in the urban environment, where they can use it via carrier aggregation, supplemental downlink, and uplink, to add significant amount of capacity at little to no cost, depending on whether they're doing it with PAL or GAA spectrum. So that would be the mobile case. And then everything else is essentially, I think we could call it verticals, if you will. So the fixed wireless use cases, I think the acting chairwoman mentioned this. There are many, both small and large wireless internet service providers who are now using CBRS to provide rural broadband connectivity, potentially residential, small business, even large business where there's just no fiber or copper assets to do it with. Alternative mobile footprint in the middle. This is really the idea that the cable operators in particular can use CBRS to roll out their own cellular footprints. So build out a LTE and or 5G network, particularly in the urban areas where they have extensive hybrid fiber coax networks. So, leveraging those to place a small cell, in the picture is actually a strand mount LTE small cell. And then going to the right end of the slide here, it's more the sort of enterprise managed service provider space. So private LTE, and again, these are very broad categories. So that could be anything from, we'll call it enterprise, but also include things like, transportation and logistics, industrial, energy. So many of those are very active in CBRS. We saw them at the PAL auction as well. But this is using a cellular technology, a 3GPP technology, to meet internal communications needs, right? So the final block is essentially then also using an indoor LTE and or 5G deployment to support the subscribers of the mobile operators, or potentially the cable operators as they deploy mobile services. So, we've had solutions around distributed antenna systems or DASs. Those haven't made a lot of economic sense in many situations, particularly smaller buildings, ones that don't have very large numbers of public visitors or guests to them. CBRS really unlocks the potential for small cell neutral spectrum deployments that can then be opened up to the mobile operators. So the private and the in-building cellular, those are really somewhat overlapping. There'll be entities that deploy simply for a private internal communications needs, but I believe there'll be many deployments that are done for private needs, but are also then opened up for in-building cellular neutral host deployments. Next slide, please. So in response to this opportunity, this range of use cases, this is a snapshot of the Alliance. We were formed, we launched almost 5 years ago, August of 2016. And we had 6 founding members. We're now at 190 members. So I think when the acting chairwoman talked about the robust, strong industry response to CBRS, in a nutshell, this is it. And it's a bit of a who's who, both in the, with the tier 1 mobile operators, the largest cable operators in the country, cellular infrastructure vendors, enterprise wireless solutions providers, tower companies, neutral host providers, and then a range of folks really representing the end user community. You'll see universities in this list and people representing multi-tenant dwelling units. So it's a bit of, it's eclectic, and I think that is really reflective of of the opportunity and what happens when you create a flexible framework like this. Next slide, please. So just a little bit of an update. We got our initial commercial operation authorization in September of 2019, and then we got our full commercial authorization in January of 2020. So we've been operating commercially, with full commercial authorization for almost 16 months now. And in that time, we've seen almost 150,000 radios, or CBSDs, as we call them, deployed in the field. I don't think there's another example globally of that kind of acceleration and takeoff in small cell deployments when a band has opened. So I think that again really underscores, the success of the vision that the Commission had here. Those radios, there's a mix of GAA and PAL now. We did the PAL auction last August. We've recently actually put the PALs into service, so we now have PAL, the final piece of the puzzle, operational in the field. Category A, Category B, indoor, outdoor, and really the range of use cases I articulated previously. Coming back to the equipment, I do have one additional slide on this, but we now have over 130 different models of the infrastructure radios, which again we call CBSDs, Category A and Category B. The FCC has authorized over 130 different models of those from different vendors. 220 plus different client devices. And the client devices really kind of going back to the point about an ecosystem forming, when you're able to leverage global scale. Because of that, we've got, certainly we've got mobile phones and things like this, and some tablets and laptop form factors and the things you would expect. But we've also got things like ruggedized IoT modules and gateways, consumer grade gateways, a lot of customer premise equipment for the fixed wireless use case. And then some really interesting sort of mission-specific client devices, security cameras that now have integrated CBRS capability, barcode scanners. So it's really pretty amazing the kind of clients that have come forward with CBRS support. We now have 9 authorized SAS administrators, the Spectrum Access System administrators, a bunch of certified professional installers, and then we also have launched our release 3 specs. Actually, we did that about a little over a year ago, that support 5G new radio in the band. Next slide, please. This is a snapshot of how the equipment ecosystem has evolved since the full commercial authorization. And I just want to leave you with the fact that it's on the right trajectory, and the interest in deployments and the interest in supporting CBRS from both a client and an infrastructure perspective has continued to grow steadily during that time, and actually accelerate a little bit on the client side. So we're very excited about how the ecosystem continues to form. I would point out probably, well, on the client side, almost all of this has been LTE equipment. On the infrastructure side, some of the newer models definitely have NR support, 5G NR support. But what I think is going to fuel a lot of the growth going forward, particularly on the client side, will be the introduction of clients supporting N48, which is the 5G NR specification for the CBRS band. Next slide, please. Just a little bit on the kind of going again back to the vertical segment. These are some of the leading segments that we see that are very active with CBRS, and a lot of trial activity and now deployments are happening in these sectors. So I'm not going to list them all, but I don't want to get ahead of Q&A or anything. But a question that often comes up is how does this relate to Wi-Fi? I see it as very complementary technology to Wi-Fi. Yet there are things that unlicensed spectrum and or Wi-Fi technology sometimes don't do extremely well, whether that's mobility, range. There can be some concerns about security, although advanced Wi-Fi solutions do address many of those. But in any case, there tend to be gaps around Wi-Fi solutions in many of these different sectors, and so I think that's why you're seeing CBRS activity here, and why these are some of the ones that are really pushing hard, forward with CBRS deployments. Next slide, please. Did want to touch on the PAL auction. So we've heard about that a few times already. $4.6 billion was raised. It was 23,000 licenses that were up for auction. And, I think we've heard a couple of times already, 228 different entities secured licenses at the auction, which, far surpassed anything we've ever seen at an FCC auction before. The acting chairwoman talked about, her view of how successful this was. There's a statement here from, her predecessor, Chairman Pai, about his views on it. And then, just looking at the list or the chart on the right, you'll see, sure, Verizon was the top bidder in terms of the gross proceeds or payments, but Dish, Charter, Comcast, operator representation. But then very quickly you see, leading utilities, Southern California Edison, San Diego Gas and Electric, and then a range of other entities participated as well. So if we move to the next slide. This is one of my favorites, and these, I should attribute these slides to Sasha Javed at BitPath. He presented these to our membership back at a meeting we had a few months ago, so I'm using them with his permission. But Loving, Texas, which is a rural county in western Texas, was the most expensive county at the auction on a dollars per megahertz pop basis at $141. And why is that, right? It's because there's like 80 people in the county, at least as of the last census. But there's a huge interest there in securing these PAL rights, particularly from the petrochemical industry. So you'll see, Chevron, Local Loop, Oxy, EOG. Those are essentially all energy and petro companies. So again, unusual suspects participating in a spectrum auction. Next slide, please. Another example, so this one is also of interest, where in Arlington, Virginia, we had an entity called JBG Smith, who secured 4 of the 7, and again, the maximum that you could get in a county was 4 as a single entity. So they secured the most available licenses that they could in Arlington, which is just outside of downtown Washington. So this is a very, this is a prime location. And it turns out this is a JBG is a real estate investment trust, and they're the developer of the next generation Amazon and a university. Virginia Tech is building a campus here, and JBG is the developer, and they have some very innovative ideas about how to use CBRS and the ONGO solutions in the band as essentially an amenity to attract their commercial tenants and to be utilized by companies like Amazon and the university. And I think that's it for me. I will turn it back over to you, Michael, and look forward to the discussion. Oh, I think you may be muted.
Okay, thank you, Dave.
Yep.
That was great. Next, we have Chuck Lukachevsky, who is Vice President and Chief Wireless Technologist at Hewlett Packard Enterprise. Chuck?
Good morning, good afternoon, good evening. Can you hear me?
Yes.
Great. So we're going to turn now from the 3 gigahertz band to the 6 gigahertz band, and specifically we're going to look at one of the device classes in the band, which is what the FCC has called standard power. And that device class, because it's an indoor-outdoor class, is required to be controlled by an automatic frequency coordination system, which is a form of a spectrum database similar to what David was just describing around CBRS and white space. Let's go to the first slide, please. So I just want to start by sort of putting this in context and complementing. I really want to acknowledge both the Canadian regulator ISED as well as, of course, the US FCC. I said as part of its 6 gigahertz decision is proceeding with all three device classes, including standard power with AFC. And this has actually created a very interesting common market, and I use that term deliberately. So between essentially in North America now, we have the single largest common market for database managed spectrum, which is really an amazing milestone. For those who have been active for so many years around, white space and CBRS and other forms of database management, to be able to sort of even talk with this vocabulary is a testament to all the building blocks that have been put into place over time. So I'll start in the lower right corner here. So Canada has authorized AFC operations across a contiguous block of 950 megahertz of spectrum from 5925 up to 6875, which is the most in any country. The US, of course, went first by authorizing 850 megahertz. You'll see this 100 megahertz notch at 6425, and that's due to the presence of mobile users in that segment in the United States that Canada does not have. But collectively, the two countries account for 26% of world GDP, 370 million population, right, between the two countries. I don't know, this next metric is just sort of informational, 13% of world land area. I certainly would not imagine that we're going to have radios, pervasively above the Arctic Circle, but, who knows. But more interestingly, if you take those spectrum values times the population, you get a total of 318 billion AFC megahertz pops in this common market, which is really, really compelling from a manufacturer's perspective. And it is these two countries collectively represent, according to the market research, fully a third, or 33% of the market just for outdoor RLAN devices, and that market is estimated to be, not quite, just shy of $500 million per year, and it is a critical market segment. While it's not as many units per se, the average price per unit is considerably higher because this equipment tends to, it's ruggedized. It supports a variety of attachment modes and accessories and antennas and so on. And it's heavily used in a wide range of enterprise verticals, from oil and gas to container and intermodal transportation terminals to stadiums, public safety applications. You can go on down the list. So we're very excited about this development because as a significant provider, we're one of the two largest manufacturers of our outdoor RLAN equipment. This really creates the critical mass that we need to have a complete product portfolio here. And I'll just close on this slide by pointing out that this is not just outdoors. So we're not going to talk about low power indoor here, but that's another one of the device classes in 6 gigahertz. And one of the technical rules, which has been adopted initially by the FCC and then by pretty much every other country that's adopted the ban, is that to keep these devices indoors, one of the simple constraints is that they cannot have connectorized antennas on them. And that was in the past, that was one of the reasons why people did take indoor equipment and put it outside. What that means is that any indoor application that requires a connectorized antenna must use AFC because that's the only way that equipment can be deployed. And so examples here would be, think about an aircraft hangar where I need to have APs around the walls with directional antennas in order to light up areas underneath the aircraft, for instance, or in warehouses and distribution centers. Directional antennas are often used to light up long aisles, right, that go for hundreds of meters, for example, and many others. So the market for AFC is actually even larger than what I'm talking about on this slide. Next slide. So in terms of a little bit of an update for the, what's going on from a market and a standardization perspective. So the, one third-party AFC provider has already announced the availability of a development platform that was Federated Wireless, and the citation is here. Obviously, they're a very active, a service provider in the CBRS and other database modalities. So we're delighted to see them come into this market. And then 2 different prototype implementations have been demoed to the commission, one being Federated, and then Facebook has also developed and shown a prototype. Both the Wi-Fi Alliance and the WIN Forum are actively working on different aspects of standardization of the AFC system and technology. And in January, the WFA published draft 1 of a protocol to be used between devices and systems. And that's what's shown in the diagram here on the left side. So this is kind of the reference model that the WFA has, you'll find this in that document, which is a publicly available document. And these are the black boxes are the different devices that are sort of laid out in the order. And the blue lines are the protocol, the different devices in the system that can communicate with one another. And this protocol is the consensus product of 64 different WFA members, over 160 individual people contributed, and we have 4 of the authorized SaaS administrators working within the Wi-Fi Alliance, and of course they're active in WIN Forum as well. But so really good participation, and we're making good time over there. Next slide, please. So another thing that the Wi-Fi Alliance is working on, and this is they've said this, everything that I'm describing has been stated publicly by the Alliance, to help regulators expedite the process of bringing systems and equipment to market. The WFA made a decision that it was going to be, it would probably go quicker if if industry were to provide baseline test plans and test cases, and of course we're again each of these systems is building on the work of the previous one. So this was done in CBRS in particular, but also white space. So we have a task group that's actively working on 2 different test plans. One is what we call the system under test. That's the northbound test into the AFC system itself. And then there's a southbound test, and that validates that an AFC device, an access point, behaves correctly. It makes the right decisions based on information that it's fed by a test harness. Of course, the Wi-Fi Alliance is working on tests that are specific to Wi-Fi technology. Other standards organizations, for example, WIN Forum, is looking at 3GPP-based technologies, and we do expect NRU to be very prevalent in this band as well. And what I would say, just as an aside here, if you are a regulator in the audience and you are thinking about opening the 6 gigahertz band, or maybe you've already opened the band for one or both of the very low power or low power indoor classes, and you're thinking about outdoor use, one of the takeaways from this presentation is that it's moving very fast, and AFC is going to be ready very soon. We still have work to do, but hopefully you can see that we would love to have you in the common market at the earliest possible date, and there will be products available that can be certified and imported into your country. Next slide, please. So let's talk a little bit about how AFC actually works, because this is, if you're not following this closely, this may be a little new to you, and of course it is somewhat different. It's closer to white space in terms of its operating model, but there are aspects of CBRS that sort of also apply here. So first of all, you have collections of APs, or it could be a standalone AP, but a lot of the time, at least in a managed deployment, we're going to have more than one. Those could be under local control via a network controller of some kind, or they could be under cloud control. And one requirement that is in the Part 15 rules from the Commission is that each of these devices be capable of locating itself in an automated manner. So professional installation is not allowed for these devices in the United States, at least, and I think Canada has indicated a desire to try to mirror the U.S. rules as much as possible. So the device has to have some form of technology inside it, either GPS or something else, and then every 24 hours, each device is obligated to contact its AFC provider and get an updated channel availability list from that provider. And if it, for whatever reason, cannot communicate, it loses contact with the provider, then it has a short grace period, basically about more or less 24 hours, and then it has to cease transmitting. It has to stop using the 6 gigahertz band if it cannot connect. The channel availability requests include the location of the device in 3 dimensions, along with an uncertainty estimate. It uses the 95th percentile confidence estimate, and then it has to provide 2 pieces of information about itself. One is that the regulator ID or FCC ID in the U.S. and a manufacturer serial number, and that information must be validated by the AFC to ensure that the device is authorized to transmit, and then the AFC sends back information. If there are channels available, then the AP or network controller makes its own decision as to which channel to use and what power to use. And so again, in that sense, it's more like white space than CBRS. Of course, in CBRS, the SAS is making those decisions on behalf of the CBSDs. Here, it's the AFC is simply providing the information, and the devices are making those choices. Next slide. So let's look at a specific example here. So I'm showing a point-to-point microwave link. This is, of course, the primary incumbent that the AFC is designed to protect. The AFC will protect other incumbents. For example, radio astronomy is one good example, potentially FSS downlink sites. But the fixed service is the one, particularly in the United States, that we're most concerned about. So these links are FDD. So I'm going to have a receiver on both sides of the link. I'm showing, in this case, the receiver on one side, and FS links use a wide variety of antennas. They're all very narrow beam, right? The average beam width is 1.8 degrees in most countries, but some are a little wider, some are a little tighter. Some are higher quality, right, in terms of having shielding around the antenna and side lobe, rear lobe suppression. Some are not quite as good. So the shape of the protection zone that is calculated by the AFC can vary. It might not look the same for 2 different receivers depending on what antenna is in use. And then, of course, the shape is also going to vary based on the EIRP of the Wi-Fi or the RLAN device. An RLAN device that uses more power presents a greater interference risk, and so therefore the protection zone or contour is going to be larger for a higher power RLAN, as opposed to an RLAN that is prepared to use lower power to achieve its mission, in which case it presents a lower risk, and that will shrink the size of the protection zone. So in this example, if I have a RLAN device that is completely outside the protection contour, then it is permitted to use the bandwidth of that FS receiver. On the other hand, if any part of the uncertainty region around that RLAN device it either touches or is fully enclosed by the protection zone, then the bandwidth of that FS is blacklisted. It is prohibited from operation, and you see that here in the bottom in the channel plan. So in this example, this FS receiver goes from 6300 to 6330. So that 30 megahertz would be blocked out in any channelization. It doesn't matter whether the RLAN is using 20, 40, 60, 80, 100. No combination of channels would be permitted in that range. And it's entirely possible and indeed likely that, particularly in dense urban markets, there are hundreds of links that are typically existing in these areas. And so you can see on this diagram, there are other sections that are also notched out in gray. And this is a real example actually from a prototype AFC showing that in this particular location, there were something like 6 different FS links. And the net result is that you can see that we have 4 80 megahertz channels available here, and I think it's 11 40 megahertz channels. Next slide. So just very quickly, two sort of live examples to try to give you visuals to keep track of this. So here's an example. This is using the federated AFC, and this has been submitted in the record previously. So on the left side, we're looking at downtown Dallas, Texas, and the colored lines are FS links that are terminating in downtown on, typically they're on large, tall buildings, skyscrapers downtown. Again, this is very typical of a lot of metro areas. So those are just showing you the links to make it a little easier to see them. On the right side, now we're showing the protection zones that correspond to those links. And the red cross that's in the center of the display, basically we put a virtual RLAN at that location and we query the AFC. And you can see the resulting spectrum availability here. So the green channels are channels that are available to use at that specific location. And again, you can see that there's 2, 4, 6, 8, 9 40 megahertz channels, 4 80s. So there's not enough 80s to make a network, but there are absolutely enough 40 megahertz channels to make a network in this location. Next slide, please. So that's a single location. Now, what about more extended use? And so this is an example that we put into the record more recently. So let's say that we wanted to use outdoor, a common use for Wi-Fi is on trains and public transportation. Let's say that I wanted to use Wi-Fi in the 6 gigahertz band to provide backhaul from the train to the track side. So I'm going to put access points on poles all the way down the track from from one station or one destination to the other. So in this case, we're looking at part of the Amtrak line from Washington D.C. That's in the lower left corner. Up to Baltimore, which is in the upper right corner. So it's about a 32, 33 minute ride if you're on the express. And what we did was we basically went all the way down this line 80 meters at a time. So you think of the poles that would be on the side of the track as you go along. And what we're showing here, we're color coding this based on the number of full power channels that are available at each of those locations. And in the blow up on the right side, you can sort of see this. So each of these, the 2 colored lines, one corresponds to the Uni 5 band and one corresponds to the Uni 7 band. And each of the sort of the little vertical notches here, that's where we queried the AFC for that location. And you can see that, so there happens to be a tower with a number of different FS receivers and transmitters on it at this particular location. And so you can see that right away that those towers are in the Uni 5 band, and the Uni 7 band is unimpaired in any way. So there are 34 different channels, I think, in this location, even with the impairment. And of course, without the impairment, there are 59 channels. So hopefully, this is an interesting example because it shows that there is a lot of FS along this track. Some of it is next to the track, some of it is going over the track or is just nearby. And yet it's very obvious that an AFC deployment to support a rail application would be totally effective here. And so again, my message to any regulators in the audience that are considering where outdoor Wi-Fi is a significant application already in your country, is that we would very much like to meet with you to talk about how we could bring this technology to you, and it really is going to be here in the very near future. Thank you.
Thank you, Chuck. That was That was really great. And our last panelist for the lead-off remarks is Jennifer McCarthy, who is Vice President for Legal Advocacy at Federated Wireless, which is of course, a SaaS provider and other things that Jennifer will tell us about. Jennifer?
Thanks, Michael. Yes, we are indeed one of the commercial spectrum access system administrators for the CBRS band here in the United States, and a prospective AFC administrator, as Chuck just mentioned, here in the US, hopefully in Canada, Brazil, other countries. I know this topic is supposed to focus on Europe, which is a market that we would very much like to operate in, and would love to join Chuck and any regulators who are considering spectrum sharing opportunities using automated geolocation databases to enable that to happen. Whether that occurs in mid-band spectrum in 3 gigahertz or in 6 gigahertz with the AFC. Both of which we think are excellent targets for this technology to help speed up the innovation and the deployment of new broadband services, whether that be on a fully licensed, lightly licensed, or unlicensed basis. So I know my talk, I didn't prepare any slides, but I thought we could quickly talk through some of what is early stages, I think, of dynamic spectrum sharing that's going on in Europe. I know that Philip and Thomas and Alex all mentioned what's going on in their countries in earlier panels. But just to give some context for those who may not have heard all of those discussions, in the mid-band in Europe, most countries did not have the same type of encumbrances that we have in the United States. And they were able to open up the 3.4 to 3.8 gigahertz band and clear it for auctioning on an exclusive basis. And most European countries have already gone through that auction process or are in the middle of doing that and are excited to see new
Michael, are you still there?
I am here.
Okay, we seem to have lost Jennifer. Do you think perhaps you can take some questions while we try and get her back? There were a few questions in the...
Yeah, oh sure, yeah, that would that would be great. Yeah, I was wondering, I thought it was on my end initially, that's why I was running around. Okay, oh wait, maybe she's back. Jennifer? No, she's still... Jennifer, we can't hear you if you're there.
Can you say something, Jennifer?
Can you hear us, Jennifer?
I can hear you. Can you hear me?
Oh, you're back.
Great. I can't see you, but I can hear you.
Okay.
All right. I apologize for that. the vagaries of our connection are so ironic when we're talking about spectrum and connectivity, aren't they?
Right.
So where did I drop off?
I'm not sure. You would, you had given us all, the background on federated, and that you're interested in getting into Europe, but I think we needed
Okay, great.
Yeah, you were just starting to describe the state of play there.
Okay, great. Yeah, I think I was trying to describe the fact that most countries in Europe not had the 3 gigahertz encumbrances that we have in the United States, and were able to clear and auction on an exclusive basis the 3.4 to 3.8 gigahertz band. But that now that those 4G and 5G deployments are occurring in that band, they're looking at other opportunities for new spectrum access and licensing options. And we heard from Philip and Thomas and Alex in earlier panels describing the ways in which the UK and Germany have been thinking about getting creative in providing spectrum access to new users and new industries and new verticals, as they like to call them. So Philip described the shared access local licensing regime that they've put in place in the UK, which is extremely exciting. And we know that there are quite a few entities who have acquired local licenses in bands that are otherwise being shared with different services. That is being done on a first come, first service basis that Ofcom is managing, and it is on a very localized basis for each of these licenses. And as Philip mentioned, they are exclusive for that localized area. Whereas in Germany, they decided to take a different approach and to set aside 100 megahertz of spectrum in 3.7 to 3.8, I believe, for their verticals to act spectrum that is otherwise under the umbrella of the 3GPP bands for the 3 gigahertz range. And both of these approaches we think are excellent ways of trying to increase access by different entities to critical mid-band spectrum. We do have a bias at Federated Wireless, and probably from the United States, in that we think that it is an opportunity to automate this kind of capability and to make sure that the spectrum is maximized to the greatest extent possible. And we think that the way to do that is to rely on technologies that have been developed, database technologies that are automated. I think last night it was mentioned by Agostino from Brazil that exclusive spectrum might be the old school way of managing spectrum. We also think that manual spectrum coordination and spectrum might also be old school, and that automation is going to really help drive maximization of spectrum usage, maximization of opportunities for the greatest number of new entrants and different types of verticals, and that having the knowledge that that a bright line tests, we set up the rules in advance what the interference protection requirements are for any existing incumbents or for new users to protect one another. We think that those bright line tests can be implemented into automated database solutions, and that will provide the certainty that's necessary for people to feel confident about going ahead and making investment decisions, and knowing that they will get an answer virtually immediately from an automated database system, and knowing what the rules of the road are going forward will just, again, speed up innovation, deployments, and increase broadband access. So I know we're looking to, expand the conversation. I think there are a lot of additional opportunities in Europe for more shared spectrum access. We talked about 6 gigahertz and the lower half of the band that's being made available there in Europe for lower power operations. But as Chuck just described in wonderful detail, we are hopeful that the entire band could be made available and that all of the different unlicensed use cases, including higher power and outdoor operations, will ultimately also be authorized. And we are ready with our AFC to adapt that capability to the European markets, knowing that they've got different challenges with so many different countries, with different national regulatory regulators and regulatory approaches. Cross-border issues are going to be, a big issue, as are making sure that all of the databases that the regulators need to enable these kind of dynamic spectrum sharing approaches to work. Those databases need to be developed, they need to be accurate, they need to be up to date, so that we in turn can interface with them, rely on them, and ensure that that any incumbent services are actually protected, and that we know how they migrate and change over time, so that we can adjust the sharing parameters accordingly. So looking forward to working with Europe on expanding their 6 gigahertz decision, and on opportunities in other mid-band spectrum for sharing. The possibility, I think, exists for 3.8 to 4.2 for sharing opportunities there with the satellite systems that are in those bands. We've got experience in the US of sharing and with FSS, and we think we can implement a similar type solution for the 3.8 to 4.2 band. And with that, knowing we're running out of time, Michael, why don't I turn it back over to you and let the panel respond to questions from the audience.
Okay, thanks, Jennifer. That's good to pull in some of the updates, because Europe is definitely, trying on some of these same innovations in spectrum sharing. So I don't see an immediate question in the chat from the audience, but I do definitely have a few that came up based on the presentations. So let me start by, I think I'll direct this at Andy, but any of you can jump in, of course. Andy, you mentioned that in the US, the 3 gigahertz band is becoming a bit of a checkerboard with high power exclusive use on each side of CBRS, and the possibility of CBRS like sharing below 3450, where military radar seems likely to continue operating. How much of a problem is this, and how can the FCC deal with it?
It's a little bit of a challenge. You say checkerboard, it's a good description. So for example, below 3450, we'll probably, maybe in the future have some kind of CBRS like sharing. Then 3450 to 3550, we have, kind of lightly shared. And then we have CBRS like sharing in 3550 to 3700. And then we go back to unshared high power operation at 3700. So it sort of alternates high power or low power, high power, low power, high power, and shared, not shared, shared, not shared. At each of those boundaries, with the high power, there's the potential for causing interruptions to the adjacent band services. The FCC's addressed it a little bit. They haven't adopted really any rules to require TDD synchronization, for example, or something. But they are addressing it, and I think whatever experience we have having 3.45 gigahertz with coexistence with CBRS will pretty much set the standard for how the FCC is going to have to deal with this going forward.
Thanks, Dave, or anyone. Do you have any other comment on that?
I'll just remind people of what Andy communicated earlier, right? So both 3.7 and 3.45, essentially the maximum ERPs are in the 3,200 watts per megahertz, whereas the maximum EIRP in the CBRS band is 5 watts per megahertz. That's what the category B radios that I talked about. the category A's are 1/10 of a watt per megahertz. So, that power imbalance is significant, and Eddie was absolutely right. The FCC encouraged some multi-stakeholder coordination in 3.7. We did talk to them about the ESC network that's responsible for protecting the federal incumbents from 3550 to 3650, so the lower 100 megahertz of the CBRS band, and some of the concerns that we had about the introduction of the 3.45 radios in proximity to those ESC sensors along the coast. So far they've said, well, ESC is protecting a primary service and therefore is treated as a primary service, and any interference to the ESC will be considered harmful interference. So, at this point, we're continuing to work with the Commission, as well as NTI and DoD, who are, as Andy pointed out, have been great partners to us on how to mitigate that situation potentially.
Okay, great. Well, we have a couple, two questions from our viewers about CBRS. So let's stay with that for a few minutes. One is directed toward Dave and Andy again about PAL license duration. Asking, isn't 10 years a long time for a single entity to own a band considering the current technology development rates? And I invite you to explain, the way that was originally intended to work, but where you think we are today with that on that issue.
Yeah, I'll jump in, and then Andy can fill in any gaps. But the original rules were 3-year licenses, so much shorter and also much smaller geographic area, right? So census blocks versus county level. FCC did revisit those rules, and we ended up with the county level 10-year licenses. It's one of the side effects of trying to create a band that appeals to so many different use cases and constituencies. And so, I would say the mobile operators as well as the cable operators really said they needed, a 10-year or longer license. I guess cable maybe said 7, if I remember the record correctly. But they wanted longer license terms in order to be able to ensure that they would be able to, essentially recoup the cost of the licenses in the auction process. Try to balance that with the needs of new entrants, smaller entities, and actually, while I'm on the long term, the folks who are in favor of longer terms, even some of the industrial players said, if you really want us to pony up, the millions or potentially billions of dollars necessary to secure some of these rights, we want an assurance that we're going to be able to operate for 5, 7, 10 or longer years. Kind of coming back to a point I made during my presentation, it's important that people understand, in addition to just all the sort of foundational innovations that are in the CBRS framework, the Commission also worked in some other really, I don't know if revolutionary, but certainly new types of incentives to make unused PAL rights available to other entities, and that was the secondary market that I talked about. So, at the highest level, if you bought a PAL in a county and you're not utilizing it in certain locations, it's available for GAA use, right? So we're only obligated, the SASs are only obligated to protect the operating areas around the PAL radios. Anything outside of that within the license area, I can come in and I can use it without having paid the Commission, anything by way of a license, right, at the GAA tier. So given that, and given the fact that it's because we have the SASs that are coordinating the spectrum environment, they're aware of where these PALs are operating. They're certainly aware of where the county delineations are. It would be very easy for a SAS to then work with that PAL license holder to say, hey, if there's areas outside of your operating area within this county, would you like to make some money by licensing, by leasing those rights to other entities? And and play a matchmaking service with smaller entities who might want a localized license for a shorter term than 10 years. So I do think that's going to happen.
Yeah, and it's a good point. I mean, if I just add quickly, good point you make about the sort of what's unique in combining the licensed with the general authorized access under the same operating rules and the same band it means that there always will be spectrum there available. So even if those licenses are all purchased and operate indefinitely, for example, there are school districts in a half a dozen states that have been during the pandemic began using the GAA portion of the band to deploy private LTE networks that extend the school networks to connect students and teachers at home. So it's not actually, the larger license areas, we were not a fan, but they're certainly not precluding many innovative uses. Jennifer, I'm sorry.
Oh, no, I apologize. I was just going to build on the discussion that you and Dave were just having in terms of sort of the ancillary benefits of the spectrum access system that we put in place, mostly, to help manage the sharing between the commercial users and the U.S. federal, the U.S. military. But some of these ancillary benefits are, as Dave said, the ability to assign spectrum that's being unused by the license holder to new entrants, whether that's on a use it or share it unlicensed basis or through that secondary spectrum market. The streamlined process that the FCC's put in place, where spectrum access administrators such as ourselves or Google, others, can help play that matchmaker. We've already announced that we're ready to go with that secondary market capability. We've been testing with the FCC and the other SAS administrators how that would function. And I think this capability is something that could easily be ported to other countries, including those in Europe, for existing bands, where existing licensees and operators, if they have unused spectrum assets that they'd like to make sure get used and to generate some revenue from, a spectrum access system or something similar to that could really be helpful and used on an even voluntary basis to facilitate greater use of spectrum, and it'll be a win-win both for new entrants who want access to spectrum that might otherwise be tied up, as well as providing licensees with a way to generate revenue for any unused portion of the spectrum that they have.
Right.
Michael?
And there's a related question in the chat, which I can ask, especially with two SAS administrators here. Are there any metrics yet to show sharing success or failure between the licensed networks and the unlicensed users? In other words, between the PALs and GAA in the CBRS bands? Does the equipment manage the sharing?
Michael?
Yeah.
Yeah, if I can jump in, I don't have a large data set. Maybe Jennifer's in a better position, but I just want to comment as a large equipment manufacturer that recently entered the CBRS market. Right, we announced in November that we have a solution, and it's Hewlett-Packard Enterprise. We're very excited about this band, and I just want to underscore the regulatory decision that is novel, one of many that's novel here, but is this use it or share it concept, and it goes directly to the question, because if that requirement was not part of the rules, then what would happen is you'd have in effect 80 megahertz that was committed to PALs, and a smaller amount of spectrum that was available for GAA. And we'd sort of have to take a wait and see to see where the PAL equipment got deployed, and we'd have to wait to deploy anything until it got there. What use it or share it does is mean that you have a market immediately where anyone that wants to can go deploy, because it's going to take a long time for these networks to propagate, and so it creates the certainty that's necessary for equipment manufacturers to come in and then start talking to customers about how they could actually benefit from and deploy the technology. And we're starting to see a lot of very recognizable companies here in the United States who are doing CBRS trials specifically because in GAA, specifically because they can get going now and there is no sort of wait and see.
Right, exactly. So since we're approaching the end, running out of time here, I'm going to combine as a last question to y'all, I think combine two questions concerning 6 gigahertz and the use of AFCs. So, two-part question. One is, what do you anticipate will be the cost, more or less, of relying on the AFC for 6 gigahertz access? And do you think the efforts around the AFC specifications in the U.S. can apply to other countries? What would be the common, the commonalities or differences if you wanted to start extending that beyond North America? So, Chuck, you're probably in the best position to start off. I don't know anyone else wants to jump in.
Sure, I'll go fast, and then maybe Jennifer wants to weigh in. So, I mean, on the cost front, certainly it won't cost more than CBRS. It's a simpler system. I don't think we're going to get into numbers today, but it doesn't have aggregate interference protection requirements. For example, you don't have the AFCs don't synchronize with one another, so the implementation and operating costs are not what they would be for the CBRS system. I can tell you, just as a significant provider of equipment in this space, that we're optimistic that it's going to work for our customer base. In terms of applicability, yes, absolutely, and I try to make that clear in my remarks. The rule set, we expect that a number of countries are going to essentially mirror the U.S. requirements. We were very gratified. We worked hard with the FCC on everything from the path loss models to the operational rules, and so the 6 gigahertz order is very complete. There are just a handful of things that one would need as an AFC that aren't in there, and those things are not there because we felt it was better that they be just decided at an industry level, and they might be subject to change. For example, the building entry loss value, for instance, is not in the order. So I'd encourage any regulator that is in that has a need for outdoor RLANs in 6 gigahertz to absolutely get with someone like Jennifer or one of the AFC providers or any of us at the Wi-Fi Alliance, and we would be delighted to see those rules mirrored. And please, you can join the common market, right? It should be a lot more than 2 countries.
I would agree with everything Chuck just said. Our goal is to make this band successful, and obviously it's going to be an even larger market than what we've already achieved for CBRS. So we want to make sure that the AFC is as successful as possible, and we can see different business models and approaches towards recouping costs for our AFC services and possibly bundling them with CBRS if those two things are available. Obviously they're available in the United States, but down the road in other countries, and other value-added services that we can provide, operators and regulators alike. And then I just want to get back to the previous question on CBRS and whether or not there are any metrics to show the success or failure. We're in very early stages right now of the PAL deployments. It's only been maybe a month and a half since we started implementing the PAL side of CBRS band. So it's early stages still, but I'd say it's been very successful so far, and that the rules that were put in place to ensure the coexistence between GAA and PAL users is working well as between different PAL licensees. And it's the beauty of the system is that we spend a lot of time up front making sure that that all of the functionality was built into this system, and working with all the vendors to make sure their equipment could connect, and that all of the necessary messaging and information was getting to the right places. So CBRS is relatively new, but it was a long, careful planning to make it the success that we see it to be today, and we believe it will continue to be for years to come.
Andy, apparently we do have another minute or two, lots of questions in chat. Andy, are you seeing problems with the coexistence of PAL and GAA in CBRS, and let me add on to that for everyone. There's a question about whether unlicensed or opportunistic use in these bands, whether it's CBRS or 6 gigahertz, pollute the band, and is somehow creating long-term problems. And if you could maybe address that as well, but Andy, since Google's a SAS administrator, it'd be great to hear your view on if the coexistence is working well.
Yeah, so as Jennifer mentioned, PAL deployments are fairly new. We just started PAL deployments about, I think, 5 weeks ago. We've not had any significant complaints of interference into PAL due to GAA, but also, as Jennifer mentioned, there are specific rules and industry standards that protect PALs from GAAs. There's FCC rules, and then there's the way we implemented those rules and standards. And those seem to be working well. And to just give you sort of a parallel metric, we have similar rules for protecting incumbents. We have aggregate interference limits and things like that. And CBRS has been operating now for 18 plus months. There has not been a single case of a protected incumbent reporting interference from any CBRS devices. So our whole interference framework seems to be working. What they didn't ask is, are there instances of, interference among the GAA devices? And that I'd have to say, yes, we've had to deal with a few cases of interference among GAA devices, but in reality, that's how the band was more or less designed. GAA, again, not unlicensed, but sort of like unlicensed, anybody's free to do it. And we've had to deconflict on at times, but we've managed through it, and everybody generally seems to be happy. I don't think GAA as the lightly licensed underlay really pollutes bands. I mean, I would say, it's given tremendous opportunity for people to use the band that wouldn't have otherwise been able to afford a license or go through anything. So I instead of polluting the band, I look at it as providing tremendous opportunity for people to use the band that wouldn't otherwise have been able to use it.
Yeah, an intensive use of the band. Dave?
If I can jump in on that one, I'm going to go back to Philip Marnick's comments earlier from Ofcom, where he talked about their initiatives around spectrum sharing. And if you heard him talk, it was a lot of it was about making sure we're appropriately protecting people, but we're not overly protecting people, and that we're reutilizing spectrum where and when it's not being used by an incumbent or a license holder or what have you. And I frankly think that's exactly what CBRS has enabled. It's sort of like the old story about if you fill a box with bowling balls, is it full? Well, it looks full, but then you add in the marbles, and then you add in the pebbles, and then you add in the sand, and eventually you put some water in it, and it really is full. But there's always room to squeeze in things around the edges, and I think that's what dynamic sharing, specifically with the database coordination, enables.
Great analogy. So any last comments from anyone on the panel? Because that would...
Michael, to that,
yeah, Jennifer.
to build on what Dave just said, I think one of the other major benefits of the automated approach that we've implemented in CBRS and are about to implement in 6 gigahertz is that we're going to learn as we go along, right? We did a lot of careful planning up front to make sure that we were putting in the necessary protections for the incumbents, for those folks who have invested in PALs. But we're going to learn, we're going to have machine learning, we're going to have human learning. We're going to be able to hopefully relax some of the protections for incumbents if we find that there is room for additional elbow room for new commercial users. I think power level increases are a possibility. I think out-of-band emission limits might be able to be reconsidered. And, as we look at bands in the nearby vicinity to CBRS and elsewhere, we also think we can extend this same sharing framework into those bands, regardless of whether or not there are incumbents that need necessarily to be protected. This combination of licensed and unlicensed with the same equipment interoperability really has a lot of benefits, as Chuck mentioned earlier. So I think this automated capability will continue to evolve and improve, and there's a lot of promise for to fill that box with pebbles, sand, water, whatever you want to put in there.
Yeah, that's a great point, because it's a reason for other countries to get into the AFC game, because these things build on one another. The US, I believe, was first with CBRS because it had done TV whitespace prior to that, and now AFCs, which are a simplified version of the SAS systems in CBRS. And as you said, these things will get easier and easier to extend to new bands, really unlocking untold capacity in the future. Any other final comment? All right. Well, I want to thank our panel. You all just conveyed more information than I could imagine we'd fit into this hour. So I'll turn it back over to the team. I believe Tom is, has found his online voice, and we'd like to hear from him. Thank you.
Thanks, Michael, for an amazingly rich session. We've gone from high-level perspectives of regulators to detailed deep dives into mid-band. But now, to close out, we'll hear from Tom Owero. He's the Director of Frequency Spectrum at the Communications Authority of Kenya. And let's hope that it works this time. So, Tom, are you there? What a pity! It doesn't seem like we're succeeding in bringing Tom online. Oh, there we are. Hold on. So, we still can't hear you for some reason, Tom. I don't know what's happening. I'm afraid if we can't get it working now, we may be able to try again tomorrow. But if not, we're very, very sorry to miss your speaking, Tom, and thank you for being so patient with this process. That brings us to a close then for today's session, and just a reminder that the Global Summit starts a little bit earlier tomorrow. It starts at 8 a.m. Eastern time. That's noon UTC, and we'll have sessions from national regulators and a session on the economic benefits of spectrum sharing. And finally, we'll have a panel hearing from WISPs. So we look forward to seeing you then. And thank you for staying with us. Bye for now.